Good evening, everybody. Pete Meyer, Motor Age Magazine, here with you, and kind of a new situation for us. You can see you're probably looking at a split pane right now with my friends G. Trulia and Pierre Rispo up there in New York State. Guys, how are you doing?
Not bad, Pete.
Very good. How are you?
Good to see you back.
I
I mean, we were here all in one piece a couple of weeks ago, but
yeah, we sure were. For those of you who are coming back from that, we had some technical issues from our streaming supplier, which kind of rendered whatever you guys and gals could see pretty much useless. So we decided that we were going to reschedule it, and I couldn't make the trip back up like we would normally do, and we'll continue to do when we start the series again in 2022. But we wanted to make sure that we got this information to you. Both Jeannie and I and the folks at TST, we all feel very strongly about making sure that we can provide you with resources that you need in order to take care of today's cars. So, Jeannie, do you have anything else you'd like to say before we dive right in?
well, I want to welcome everyone back. If you were on a couple of Saturdays ago, stuff happens like Pete explained, but you know what? We're here tonight. That's what really counts. And maybe I wish I was down in Florida right now because the weather's a lot warmer than here it's in New York.
And there's no snow, I'm sure.
Well, we don't have snow yet, but upstate they have snow. So welcome everyone. Let's roll with it, brother.
Yeah, a few things at home, homework before we dive right in. Well, in fact, let me pull that up, and we'll just get cranking here. Slide that over there. And again, bear with us, guys. This thing has several moving parts. G has the help of the Doreen and Pierre up there. So I'll be by my lonesome on this end. So I'm pushing a lot of buttons to make all this work. So let's get started. Again, tonight we have ignition, understanding the intricacies of modern ignition systems. Let's see what we can get started here. Of course, this is the sequel to the one we were going to hold a few days, on the 20th, Saturday, a couple Saturdays ago.
Yeah, about a week.
Of course, we've got to thank the folks who are making this all possible. Sponsored by our friends at Duralast. If you want to learn any more about their fine product line, including their vehicle electronics line, which is some of what we're talking about tonight, visit duralastparts.com. Now, first, of course, we have just some regular webinar stuff to take care of. If you're watching on the Motor Age Training website, you should see something similar to this with your player in the middle. Of course, you recognize it. We went with YouTube tonight to make sure we didn't have any issues. And of course, the YouTube chat window that you guys are already using. And you should see, if you're on that page, you should see a link to the handout right above the player. If there is some reason that you can't access it for any reason, don't fret. We will give you some email addresses here. You'll see it in a few minutes, and we'll do it again at the end. If you email me, I will make sure that you get a copy of it, okay? So if you can't access it, it should be on your account page as well, all right? And here you go. Don't forget when you're done, if you're again on the Motor Age set, you can go back to your account page where you launched this program, and you'll see the link there that you can actually print out your certificate of completion. If you are an instructor in a high school or secondary school program, you can use tonight's presentation for continuing education credits for that. Now, in terms of the chat, guys, I'm going to really try to do my best to keep an eye on that and to try to answer them as we go. But like I said, there's a lot of moving parts with what we're doing tonight, so please bear with us. Our main focus is to make sure that we get the information out to you, okay? So let's go ahead and get started in the meat of the matter. Here are the email addresses. You can make a note of that, screen capture, take a picture of it, whatever. Those are email addresses that you can use to get the handout, or any questions that you might have related to tonight's topic or anything else automotive related for that matter. We'll both be willing to do what we can to help you out. And here's what we're going to do in the first half. Now, I promised everybody, because of the fiasco that we had on the 20th, I wanted to make it up to you guys. And Gene and I both felt very strongly about this. So we put additional material in tonight's presentation that we didn't have in the original presentation. So you're really kind of getting like a twofer for tonight. And I hope that you'll find that the time you spend with us this evening worth your while, all right? So let's see what we're going to look at tonight. We're going to take a look at, in my part, what components make up a modern ignition system, how does the ignition system work, what testing methods you can use using your DVOM, and what are some effective scope techniques that you can apply to the system. And we're also going to take a quick look at what diagnostic information can be found in the ignition pattern. Now let's start off with this. Yes.
Hey, Pete, let me just add something there that
Please.
As we're going through, if anyone has any questions, please ask them and we'll be able to answer them for you.
Yeah, absolutely.
Take it away.
The G-Man's back there in the background. You can see him in his little PIP window in the bottom right-hand corner. So he hasn't gone nowhere. He and Pierre are standing by there to help us answer the questions and make sure we cover everything. I see a few comments here on the login for the handout. I'm really not sure what you're referring to. If you can log into your account, if there's a problem with the link, tell me, guys. If there's a problem with the link, that you can see the link, but it just won't work for you, tell me that. That's a little different situation, okay? If you can't log into your account, well, you should be able to that because that's your account. If you go to that account page, you should be able to log in and then access your list of programs that you've watched. All right, so let's get back to it. There are three essential ignition systems that we've used in automotive applications. The first, if you've been around a while, you remember the mechanical breaker point ignitions, distributor-based ignition system, which later evolved into the electronic ignition system, still distributor-based. And then from there we moved to distributor-less, and now most common are coil-on-plug. And even though it's one family of ignition systems, there are actually three different kinds of coil-on-plug. We have the 2-wire, the 3-wire, the 4-wire, and even that has a couple of subcomponents, the feedback circuit and one with a double ground. Now let's take a look at this one first. So before the computer era, systems were mechanically operated. And you can see here, this is an old distributor type ignition with mechanical points. And the thing I really want to share with you on this is not the fundamentals of how it works. I think everybody watching tonight gets and understands the fundamentals of how an ignition system works. What I want to stress with this particular illustration is that originally, everything was mechanically linked on the vehicle, whether it was the ignition system or the throttle or fuel. There was always some type of mechanical linkage making it happen. It didn't take a computer to operate these systems. Now, when we started switching over to computerized systems, if you've ever heard me talk about any kind of ECU controlled circuit, the ECU itself, the computer portion of the circuit, is as dumb as a bag of rocks by itself. It can't do anything unless it's been instructed on what to do and when to do it. So when we're designing these electronic ignition systems, all the same things that we took for granted and kind of worked automatically because of the mechanical linkage, now we have to make them happen, and we have to tell the computer what to look for, how to look for it, and what to do when it sees what it sees. It has to know where that piston is in relation to top dead center. It has to know when to turn that coil on and turn that coil off. It has to have a means to do that. It has to be able to compute how long it can leave it on, how to adjust the timing, when to fire the plug. These are all things that now we have to provide sensors in order to get the ignition system to work the way that it should, when back in the old days it was just a matter of gearing it to the cam and then a little lobe inside the distributor, opening and closing the points, okay? Now, of course, mechanical points were a weak link. That's where everything wore. In fact, it wasn't unusual to have to readjust these anywhere from 8 to 12,000 miles. But of course, it was fairly easy when they had the mechanical points. They were all pretty much very similar in how they were set. But to get rid of that mechanical, that weak link, we went to an electrical pickup instead, and now we started seeing the birth of an electronic ignition system. Then we lost the distributor entirely, and we went to the DIS, or distributorless ignition systems. And if you take a very close look, I want you to think about something here with the coils. Each coil here is feeding 2 spark plugs, aren't they? This is what we always refer to as a waste spark system. Both plugs fire at the same time, but one spark is going to be on the combustion and one's going to be on exhaust. So that wasted spark that happens during the exhaust stroke, you'll still see it, but it's going to be a lot less high in its voltage. And now we're on the coil-on-plug. Each cylinder gets its very own ignition system. In some cases, even the ignition control unit is included in the coil. A lot of things can cause a COP coil to fail. One of the most common is spark plugs that are ill-maintained. You have the gap gets so wide that it takes so much energy from the coil gets stressed and it fails internally. That's something else I want to kind of point out here. It's not just the ignition system, but many systems on the vehicle, while they're capable of producing an awful lot, say a coil that can produce 70, 80,000 volts, it's not designed to do that all the time. So if we allow the gaps to get too large, now we're requiring more energy to cross that gap. That puts a stress on that coil that's eventually going to lead to an installation failure and an internal failure of that coil itself. So that's very, very common. Another one that's pretty common is oil from bad valve cover seals, leaking oil into the plug tube and allowing it to be contaminating the boot and causing that failure. Now I'd like to talk to you about a word on timing. Timing may no longer be adjustable, but can the engine still get out of time? Sure it can. But there's no way to check that anymore, is there? So I'd like to kind of ask you real quick here, how would you check timing on a modern car? How would you do it? Let me see some of your answers. There's a slight delay, so I'll wait. How would you check timing on a modern car? There's no marks on the pulley, is there? You can't hook up the old strobe timing light and look at anything. There's nothing to see. And if you could, you can't adjust it. But there are circumstances that can cause that timing to go out of adjustment. That's the drivability check, and we need to be able to check that. Okay, we got a couple of answers there. Scope, cam crank sensors, scope. And you're all right on the money. Very good. All of these involve the use of a scope. Thank you, guys. I appreciate it. All of these involve the use of a scope. Now, I'm sure that a lot of you watching are scope users. You know, I'm a big scope fan. We're going to look at some stuff here towards the tail end of my half to talk about using the scope and show you some samples. But there are certain things you can only do with a scope. So any of you out there who are kind of still on the fence about it, let me show you what you can do with it. Let's take a look at that. Now, some of you mentioned using the cam and crank relationship is one way to check the timing. Now, in this case, we're looking at the crank sensor on channel A, cam sensor on channel B, and then the COP current on channel C. So we see when the plug's firing. The only problem with this is that I don't know if this is a good pattern, because what I need to look at is the relationship between the crank pattern and the cam pattern. So unless I have a library, if I have a known good that I could compare it to, this really isn't going to help me much, because there's so much variance between the manufacturers. Now, you're rather fortunate today because there are so many sources that you can go to grab a known good. For example, Pico has a library. ITN has a library of known patterns, good patterns. There are numerous Facebook groups that are sharing scope patterns and scope help with one another. So it's a lot easier today to find a known good to compare it to than it used to be. But I'm still going to encourage you, if you're using a scope and you're hooked up to a car, grab those patterns and have a nice orderly way to file those away and build your library over time. You know, something that I wish I had done, or I would have had a huge library by now. So I'm encouraging you, if If you're not building your own library, do that. Start that tomorrow when you get to the shop. All right. Now here's another way. If you look in the bottom right-hand corner, you probably recognize this. This is nothing more than a relative compression pattern. Now, if you don't know what a relative compression pattern is, by all means, throw that in the chat. I'll be glad to explain that a bit. But if you're a scope guy, you know we've talked about using relative compression numerous times in our webinars. This is a very easy way to get a general idea of the mechanical condition of the engine before I go too far in my drivability diagnosis. All I've done here is added an ignition signal to the scope trace. So I've got two channels deployed. One is that cranking amperage. The other is an ignition. Not only does this give me a point of reference if I do have a bad current pattern indicating a bad cylinder to help me identify which one it is, but what else is this doing for me? Look where it intersects the peak. Almost right dead in the middle of it. Do you think that's a good indication that ignition timing is okay? I think so. It's not perfect, but if it's off, typically you're going to see 10 degrees or more shift. That is a variance that you can see, even in this pattern. And that's not the only one. If you're using in-cylinder pressure testing, if you have that equipment, you are doing that, then syncing an ignition event to that is even better because you can really nail it down to almost how many degrees of timing advance or retard you have in a much more accurate way. But in any case, we can see it and we can verify whether or not it's where it needs to be. If it's off, well, then we need to start finding out why it's off. Not unusual for keyways to break, is it? For gears to shift on the crankshaft or camshaft and throw the sync between the sensor signals out of whack? Not at all. Now, remember, ECU, dumb as a bag of rocks. It doesn't know that it's off. It just knows the input that is being given by those sensors, and it's going to act the way it was told to act, regardless. Okay. Okay, another good comment there. Thank you, Don, about using your crank cam sensor sync in your on your scan tool. I'm glad you brought that up. This is something that actually I learned not too recently. You have to use the cam crank sensor sync on your scan tool with a grain of salt. And here's what I mean by that. There are some PIDs on a scan tool, an aftermarket scan tool, that are substitute values. In other words, in some cases, this may be something that the OEM doesn't offer, or they didn't get with their information package, whatever the case might be. So sometimes they either omit that, or they plug in a value that isn't necessarily correct. And you can find this out if you're using a factory scan tool and you compare the two. So I'm not saying that that's not a bad idea. Absolutely, look at your cam crank sync as an indicator. Another thing we want to keep in mind is that more and more there are manufacturers who are telling you that if you're repairing a misfire or you're replacing a cam or crank sensor, then you have to perform a relearn of that sync. Even if it says sync, you still have to perform that relearn when you made that repair. Now, in the old days, you could drive the car around for a while and it would learn on its own. But there are many models now that you actually have to perform that using your scan tool to do that relearn. Now, when it comes to diagnostics, the most common approach is to just swap one coil for another. Nothing necessarily wrong with that approach if you can get to them all. But there are many that are hidden under different plenums and intake manifolds and so forth. We can't get to them. But you can do a few simple tests at the COP connector to save time and then help verify the issue before you put it all back together. So in order to do that, you understand what time a coil-on-plug system that you're being asked to test. So we have to identify that first. So let's start there. Three types, as I mentioned. 2-wire connector, the 3-wire connector, and the 4-wire connector. Let's start with the 4-wire connector. Has 2 variations in addition to being a different design. One is the integrated feedback circuit, which I have a sample of here in the shop. And the other is a double ground COP. Okay, so Saul's asking a question here of us. Let's see. Cam crank from the scan tool is data being processed by the computer, and the scope is more of live data. Yes, absolutely. And that's another great reason for doing what I said earlier. You treat that with a grain of salt. If you can compare it with the scope, if you have access to that, absolutely the best way to do it. But sometimes you don't have to go too complex to do the test very simply. Always make sure you've got proper spark first. Let me see if I can grab that out of here. Digging in the toolbox. There you go. And I'm going to just bring that up to where you can see it. You know, this is nothing fancy. It's just a basic ignition tester. If you've got one of the old HEI ignition testers, you can use that too. Back in the day when I got started, the easiest way to test for spark is we pulled the plug and we laid it up on the valve cover and we cranked it over, and if we saw spark going across the plug gap, we were okay. But that was back in the days when coils didn't produce more than 20, 30,000 volts. There wasn't that much of a pressure on demand on the spark as it is today. It's different when you're now putting that spark, or asking that spark to occur in first what's kind of a lean mixture, right on the very edge of lean, and under a lot of pressure by the compression pressure. So there's a lot of more demand on that. If you can see spark going across a plug gap, that doesn't necessarily mean there's enough to get across the gap when it's under those circumstances. So using a tester like this one, where I can adjust the amount of air gap to kind of correspond with the voltage output I expect, well, now I can really stress that coil and see if it's able to do what it needs to do. So it doesn't take much. Very simple tool to have. All right, let's start with the 2-wire coil-on-plug design. This is off a Ford Explorer 4.6. I don't have a close-up on that one, but I think you can probably see it. We all know 2 wires going in, 1 power, 1 ground. And what's the ground going to? You see it tracing down to the bottom right, going into the ECM, where there's a driver control. That's turning that coil on and off, just like the points did in our original distributor ignition systems. Now, if you don't have a scope and you want to test the system, here's a couple of things you can do. Of course, check for power first at that 2-wire connector where they're disconnected. On some, you may have to crank the engine over to see that 12 volts, so check your wiring diagrams. And if there isn't any power getting to it, well, that's the first thing you got to solve. But if you do have power getting to the coil, then you want to test the switching signal. Is the ECU turning the coil on and off? A couple of ways you can do that. If you can use a test light in many cases, connect it to B+, and then with the coil disconnected, you can insert the tip of that test light on the ground pin of the connector, and you should see the light flash or change state as you crank the engine. That's one way you can do it. You can also use the DVOM and check the frequency on that line. You should see, if it's being turned on and off, you should see a frequency that you can see measured in hertz. That'll give you an idea of whether it's being fired or not. And if it's not being fired at the connector, does that mean the computer's bad? No. Now you've got to go and check that harness all the way down to the ECU, correct? To make sure that the circuit's intact. What's one way you can do that? Well, what about, load the circuit up and see how it reacts. All right, scope testing a 2-wire coil-on-plug ignition. Connect your channel A to the coil ground circuit, and then connect a low amp clamp to channel B. Select the 20 amp scale to start.
Hey, Pete,
Zero the clamp. Yes.
Hey, Pete, I don't know if you can hear me, Pete, but
yes.
Your screen is blocked.
I see that. Hold on. We'll get it fixed.
Not a problem. And by the way, that spark tester, if you guys don't own one of those spark plug testers, you still have the old little spark plug doohickey, those things are not good. You need what Pete was showing you. We have the same thing here. So Pete will be popping on. And again,
There we go.
questions. There you go, Pete. I will shut my mouth and let you go.
No. And like I said, fellas, a lot of moving parts on this end. And when I'm making the switch between the camera that you're seeing now and the presentation that you're seeing here, I hit the wrong button. So that's why you got a dark screen. So back to
I thought we were in the
wireless
twilight
COP.
zone.
What's that? Yeah.
I said I thought we were in the twilight zone.
All right, so here you go. Again, channel A to the coil ground circuit, low amp clamp to channel B, zero the clamp before you attach to the coil supply or ground circuit, right? It's checking current, so I can go to either side of the circuit. Another good place to look at your diagram and look for the fuse that feeds the coils. Use that. Take a fuse jumper, a fused jumper, or the fuse buddy that you can get from AS Wave, other companies make them. Probably should have come with your scope kit. And use that right at the fuse. Now, you'll see the coil current for all the coils that fuse is taking care of. It might take care of all four on a 4-banger, or it may take care of just one bank on a V6 or a V8, or it may take care of all of them. It all depends on the manufacturer. You got to check the schematic to find out. This way, I can check the health of all the coils at one time by looking at the current. And now I'm using the COP that I'm actually connecting to on the ground side of that control circuit. That's my reference point now. And I can use the firing order to know which current pattern is going with which cylinder. Make sense? So that's another way you can do it. Now, I do want to make sure you understand this. Know what the max input voltage is for your scope. In some cases, you might get an inductive kick on a primary current or primary side of the coil, could be a couple of hundred volts. And if you have an older Pico, like I have an old 3000 series, that can only handle a 50 volt rather intake. All right, so make sure you know what that is. Make sure you follow the safety instructions and working practices and ensure the rated voltage for all accessories meets or exceeds the expected voltage. And if you want to avoid damage, you may need to use something called an attenuator. An attenuator. All that does is go in line between your coil lead or your scope lead and the scope. And it just steps it down, steps the voltage down. Remember, all the scope does is read the voltage going in. So we're stepping the voltage down. Sometimes it's on a 10-to-1 ratio, sometimes a 20-to-1 ratio, depending on the attenuator that you have. And that will help you protect the scope so you don't let the smoke out of your scope. If you do everything right, you should see something like this. The blue trace is the ground side or the control side of the coil. The red trace is the current for that coil. Okay, if we go from left to right, you can see that the voltage drops from about 12 volts to close to 0. But if you magnify that, you're going to find it does not go all the way to 0. That's because it's a floating ground. You may see it offset as much as 0.7 of a volt there. So if you're looking at a voltage drop, you're looking to diagnose the circuit, don't be surprised if you see that there, okay? And now as it's being pulled down, of course, we're energizing the coil. The ground circuit's closed, and you can see now we have current building in the coil, and that's what you see in the red trace. Right at the very beginning, again, if you zoom in on that, you're going to see a few little oscillations as that magnetic field starts to build. And then when we turn it off, right there about in the middle of the screen, as soon as that current drops off, that magnetic field collapses. That energizes the secondary, of course, and fires the spark plug. Now, if it's energizing the secondary, why the heck do I have a spike here and a similar pattern to the secondary? Well, when that magnetic field in the primary current drops and energizes the secondary windings, well, they get depleted as soon as that energy is discharged through the spark plug, doesn't it? And what happens to that coil? What happens to that magnetic windings or field? Excuse me, I'm stuttering all over myself this evening. That collapses again, doesn't it? And that's what induces what you see in the primary pattern. So this is really cool because a lot of times you can't access the secondary, especially in these coil-on-plug designs that we're talking about tonight. But if I want to get an idea what's going on in the spark plug, I can use this pattern to look at the same thing. Specifically, I can't use the high vertical line, what is known as the firing line. I can't really use that. That's not going to be as accurate as looking at it directly in the secondary. But I can use that horizontal line that occurs right after that, the burn line, to give you an idea. So here you can see the cylinder may be burning pretty good. I mean, it's kind of running out of gas as the burn line quits. It's going on for about 1.8 milliseconds. That's a decent burn time. And we have some oscillations at the end, indicating that there's still a little bit of residual energy left in the coil, so the coil had plenty to give. There is one thing, though, that I want you to take a look at the next time you look at any of these current patterns for any type of coil or magnetic field controlled device, whether it's a coil, an injector, an evap solenoid, whatever the case might be. In some cases, there can be a weakness in the driver that will not allow it to turn off quickly and cleanly. If that's the case, the magnetic field is not going to collapse the way it should. It's not going to be as strong as it should be, and you're not going to get that energy into the secondary that you should. So zoom into it, measure it. That turnoff should be less than 100 microseconds. If not, then you may have a problem with the driver in the ECM. All right, let's move on to the 3-wire coil-on-plug. This is off an 07 Honda Civic, and I've only highlighted one of the coils to give us an idea of how this works. Basically, it's the same as a 2-wire coil with one small addition. It has a feedback to the ECM. Take a closer look. Okay, we've got power going in, ground, and then I have a signal from the ECM to trigger the integrated ignition control module. All right, let me review that again, make sure I get everything straight. Don't want to confuse anybody. Power and ground, as we saw in the 2-wire coil, but now, instead of having the ECU provide the driver and the ground and the switching, that's now internal. It's now internal, and that's what you see there. The ignition control module actually integrated into the coil itself. Now, to test with otoscope, if there's no spark, you can use the voltage drop testing method and a substitute load to verify the power and supply and ground paths. If you want to test the triggering circuit, you can reconnect the 3-wire coil connect to the coil-on-plug, set the DVOM to hertz, the frequency, and carefully back probe the trigger wire on the connector. Connect the black or the ground lead of the DVOM to it, and connect the red lead to battery voltage and start the engine. You should see a fluctuating value. You should see a frequency as that signal is being sent to the coil. With a scope, connect the low amp clamp to channel A, select the 20 amp scale, zero the clamp, and attach it to the coil voltage supply terminal, or the wire. Again, if you have a common fuse, use that, whatever's easiest to get to. Connect channel B to the coil signal terminal. That's the wire coming from the ECU, providing that trigger signal to the integrated control module, ignition control module. Connect channel C to the coil voltage supply terminal and D to the coil ground terminal. And then you'll get something that looks like this. Okay, channel A is current. Channel B is the coil-on-plug trigger signal. Now notice how that trigger signal, again, what is this doing? It is telling that control module to turn that coil on and off. So what we're seeing here is the same thing as we saw before. That's the dwell time that we saw on the primary side pattern on the 2-wire coil, isn't it? When it turns on, it starts to energize the windings in the primary, that current building, and then when it turns off, current stops flowing. See battery voltage? If this is running, isn't this doing a voltage drop test? Sure. So I should be able to see if there's any issues with any power supply going to the coil, and then of course the last one is the ground. That's going to make sure that I have a good ground. All right, how about the 4-wire coil? As I mentioned, there are 2 different types, one with a feedback circuit and one with a double ground. Now, I've got my wife's car up here on the rack and hooked up to the scope. This is a Toyota model, of course, and it uses a feedback circuit. I think, is it Mercedes or something that other also uses one? Let's see. As you can see here, we've got, we're only tracing one coil. Take a closer look. Tracing number 4. And we see first we have a ground, common ground for all the coils. Then we have an IGF. Okay, well that's the feedback to the ECM. This is a signal that comes from the ignition coil assembly back to the computer to let it know that it did indeed fire. Then we have B+, battery plus, coming into the coils, again common. And the IGT1 in this case that's the signal from the computer to that coil to fire that coil. So I've got, and if you look down the row there, you'll see there's IGT1, 2, 3, and 4. So there's one for each coil. All right, scope testing. Connect channel A to the coil signal circuit, channel B to the coil feedback circuit. And what are we looking for? Did it get the command to fire? And did it fire? And there you go. This is what you should see. This is what you should see. Now I like current. So I've got a current pattern deployed on this one that we're going to take a look at. And I also have other lead going to ground, again, just to make sure the ground circuit's clean. Often the feedback signal, as you can see here, if the blue trace, that's the trigger signal. That's the IGT1 or 2 or 3 or 4. And the red is the IGTF. This is the feedback, and it's common to all 4 coils in this case. That's why you see as many as you do. And you can see, if you look closely at the red trace, basically it's a 5-volt signal that's pulled down when the coil fires. And the trigger to it, in this case, is about a 4-volt trigger to the coil. But you can add current to it too. And let's see, before we get to the one with double grounds, let's take a closer look. Yeah, we'll do this first, and I'll go back to the other one. So the last COP is double grounds. This is on a General Motors vehicle. It's still a 4-wire coil, but here's what I want you to see that's different about these coils. You have ground and power going to the coil, but then you look at pins 2 and pin 3. These are 2 separate grounds. I think I can trace it out here for you. Why? We have one ground for the actual coil, for the primary windings, and then we have one ground for the electronics in the coil. And this is to help it make sure that it has its own nice clean ground path to make sure that it functions well. All right, testing on that type of coil is the same as testing a 3-wire. We went over that. And if you can't get it and you want to find out what's going on, you got to check the secondary. Here's a couple of ways to do that. And I actually have samples of that. Let me see if I can show those to you real quick. Where did I stick you? Yeah. This is just one example. A lot of people make a coil-on-plug tester. It's basically just taking the pad and you're just laying it on top of the coil here and you're picking up the magnetic inductance coming from the coil. I've had mixed results with them, to be quite honest with you. Some I've had no problem with, some I didn't get anything with at all. And it's not necessarily the probe as it is the vehicle itself, different OEMs. They don't all work the same, okay? Another alternative, if you're used to what we used to do it when we had secondary leads to connect to, we had a clamp that we clamped around that spark plug wire, and that's what we plugged into our scope. Well, we don't have that on the COP, do we? But I can add them in with these HEI leads. And all I'm going to do is this basically allows me to extend the reach of that coil. I'm going to take the coil off out of the way. I'm going to plug one end of the lead to the coil, and then I'm going to plug the boot on the spark plug. And now I have a lead here that I can clamp my normal secondary pickup leads around and get the secondary pattern I want to see. Now I can look at that firing KV and I can get some indication of what's going on with the firing KV, and that's a good indication, can be a good indication of the health of the engine as well. All right. All right, we talked about that. Don't use uninsulated high tension pickups. They're designed to clip around double insulated lead only. They're not designed for direct connection to that boot or plug. When you're connecting or disconnecting, make sure you switch off the ignition, you clean the leads, inspect them for damage, clip that HT pickup over the desired lead, and then make sure they're clear of anything that's going to get it to melt or caught in something
Hey,
that's
Petey boy, do you
moving.
want to make sure you're on slides?
Oh, mine's so bad. Sorry.
There you go.
There we go. So I'll give you a moment to look that over. Again, just to recap, switch off the ignition, clean the leads, inspect them for damage. All right, now before we go to G, I want to just break away and I want to show you the actual scan screen, Pico screen.
Kill the fan, kill the car.
And where'd you go? There you are. I'm going to pull that up.
The camera?
Now, this is the.
Watch how that's blinking.
I see it.
This is all set up to run this. So let's see. We have a question here. What we consider a good burn time to look for in today's modern vehicles? That's a great question, Bob. You know, we used to look somewhere around 1.8. Now 1.5 is not unusual. It's not unusual. And I'd be looking closely at the burn pattern itself. It's kind of an old rule of thumb that if you think of the firing voltage and burn line as a piece of rope, the more you used on one end, the less you had for the other. But let's see what this one does. Let me start the car. Give me 1 second to get around to the back of her.
Why is that still flashing?
And we'll start it up.
Good on this end.
It's okay.
Maybe didn't like staying on the screen for that long. I don't know.
And
Was
let's
the
see. We'll
video on?
go ahead and turn our scope on.
Doing something still.
Now I'm just going to capture
let's
this,
just
go
make
around
sure
and turn it
all
off, and
stuff
then we'll
on.
manipulate it and take a closer
Yeah,
look.
what do you say?
All right?
What do you see now?
So my shot's closed up here. Last
All
thing I
right, so
wanna
this
do
is this shot.
fall asleep on you.
All
Turn all the exhaust.
I got it down.
There we go.
That way we
But
pop.
he's not ready for you.
Are we going to do a little more spiel
I'm
before
gonna
we
put it
start our
on.
thing? Just to
I'm
tell
gonna
them.
put it
We're
on
going to talk
spot.
about what we're doing. You may want to lift that mic up a little bit.
I got it.
Yeah, you guys are live.
We're live now?
You are. I mean, your mics are.
You might.
We're listening to
Oh,
your
my
background
mic.
conversation.
Oh my God.
Hey, I forgot to shut that off. Did they say that you sucked or anything?
No.
I'm
all
sorry.
good.
You're doing a good job.
All right, so I'm
I'm
going to go
sorry,
ahead and
everyone. I
manipulate this
apologize.
pattern. It's one of the nice things about this scope. So we can look at the different elements of what we captured, give you an idea of what we're doing. And let's see, let's bring you down all the way to there. Not quite. All right, so here's what we just captured now. This is a 2014 Scion. The blue trace that you see at the very top, that is the signal from the ECM to the ignition control module in the coil-on-plug coil. The red trace that you see, again, it's a 5-volt signal that's pulled down when that coil actually fires. And that is what's sending that signal back to the ECM that says, yep, it fired. And in some cases, you'll see this on your scan tool. It will actually be a PID that will give you the time of the burn time. Okay. The gold trace that you see, that's all that is ground. And I want to see if I'm on ground. I don't see any real fluctuations there, so I don't think I have any voltage drop issues in the circuit there that might make the coil misfire or not work the way it should. And then, of course, we have the current itself. Here, this is a little over 10 amps. Now, the beauty here is if I want to focus in on some of that, let's just zoom in on that a little bit. There we go. And I kind of clipped off my current. But again, you can see the current pattern building. So you can't get a current pattern on it. And again, I like to check them if you go to the source itself. Here I'm on the individual wire for the coil, but if you go to the source itself, and you can see all of them at one time, you can check all the coils at one time. This came in really handy on some old Nissans where they had a lot of coil issues, and they were buried on the backside. So the easiest way to do that was to actually go in and look at it like this. Remember we said about looking at the turn off. So let's see if we can do something with that. Probably a little too much. So let's back that off. Okay, that's a little better. And I don't know if you have to put any cursors out. I don't see any kind of an angular irregularity here on the vertical cutoff that might indicate any issue with the drivers. All right. All right. So, my guys are in New York. If they are ready, turn their mics on. Hello, guys. Let's see if we can get him on the old. There we go. Okay, I see he's got his on there now.
Yes.
All right.
Can you guys,
So let's go to
everyone
here.
hear us?
I'm not going to switch to New York, but I want to switch it over here to the guys over in New York to take over part 2. Let's just go up here. And it's all yours, guys.
All right.
All right.
Well, hey, welcome everyone. Welcome back. Pete did a great job. Thanks, Pete. We always like working together, but it's only 1,500 miles or so or whatever it is apart. Not bad. Well, here's what we have for you in store for the next couple of hours here. We got scan tool usage on ignition info, ignition testing. We have primary ignition, secondary ignition, voltage and current, and much more. Because if you look over here we have a live car in the bay that we're going to be running. We're going to show you some neat stuff, some different tools, and let's get through this, right, Pierre? We have
Absolutely, and we're going to kind of and not only entertain questions from you, but throw in a little tidbit here or that there on our own from life experience, let's call it,
and entertain each other.
Yes, right.
Away. I've been up since 3. You know what I'm saying? Okay, so let's look at stuff here, and again, thanks to our sponsor at Duralast. But here, when you get the first place to start, I think Pierre would agree, is with the DTCs. You first do a visual of a vehicle. We understand that. You speak to the customer. You go and scan a vehicle, right? And when you come up with stuff like this, a 301, a 303, 305, and you got an O2 fault, then a 141, another heater fault, and a catalyst, well, where are you going to start your misfire?
Now, you know what, Jerry? This is an interesting problem because it comes up all the time. People start chasing the misfires, but don't lean conditions, problems with oxygen sensor signals create misfires? Wouldn't it be nice to make sure you don't travel down the wrong path there?
And Pierre, that's a very good point. And one of the things I want to bring up here, you see it says O2 sensor circuit fault. That doesn't mean put a new O2 sensor in. That means actually check the circuit.
That's right. And by the way, don't forget the heater circuits because they can bleed into the signal circuits.
That's right.
Don't forget the signal ground for that sensor. Don't just look at the signal. That there's 2 wires for the regular oxy sensors, typically for the signal.
And
signal
let's
and
not
ground.
Forget, many vehicles like Chrysler products, how many of you have hooked up your lab scope and actually see 2.5 to 3 or 2 volts to 3 volts or so? And you go, what's that? No, it's not a new oxygen sensor. What they're doing, you're on chassis ground with your scope. Because you were always told when you use the scope, where do we go?
Hey, go to chassis ground, go to battery negative.
Battery negative.
But the sensor needs its own ground, and they float the ground on purpose so that it'll be a cleaner signal. That's what they're doing. They're cleaning it up.
So if you come across something like that, if you got a bob, the breakout box, right? If you have a bob, then all you do is go to pin number 5. You'll be on sensor ground. Or if you want, you can go back probe the other wire right there. But getting back to scan tool data, well, here's another one using the eScan. And when you see you got a misfire right here, 302, 304, okay, but we want to look at this down here. You want to see and notice only one DTC locked in, 304, came after 302. So where's our load? 11%. We were 156 degrees.
So kind of warm, but not completely warm.
That's right.
Or maybe it has a bad thermostat, and that's part of the problem.
Very good. Very good. And here, long-term fuel trim, not that bad. How about MAP? 7 inches of vacuum. Is that possible? Now, who knows what that problem would be? Is that bad, 7 inches of vacuum? Well, first of all, we have a little formula. It's MAP minus baro. Now, here in New York, where we're at, okay, even where Pete's at, but you may be in Colorado, and forget about it.
We're pretty close to sea level anyway.
We're roughly about 300 feet because we're about 40 miles north of New York City here. So roughly about 300 feet above sea level. So we would take the 7 minus the baro, which is 29, and that would give us our vacuum reading. And that's something you need to know. You could also look at what the MAF sensor's doing, okay? Remember, 1 gram per liter, the car wasn't going anywhere. It was 2,800 RPMs.
And no miles per hour.
Wasn't
under a real load. That was just kind of a idling load.
Right. And let's not forget, do not erase DTCs, because when you erase DTCs, you're going to erase
your freeze frame that you need to give you clues on how to test it, what to test next.
And like today, we had a Jeep in that we finished up. Real big job on it. You're not in the Rust Belt, but here, oil pans, tranny pans, frames, all rot out. So we had this whole big job, and Bill didn't realize it. He disconnected the battery, and of course, it was due for an inspection.
Right, cleared everything.
Everything got cleared. So monitors need to be run, and now we got the vehicle for another day. Okay. Now here is a good one, Pierre. What about this?
PO300, which does not mean it's random. It means the computer had a little difficulty assigning it to a cylinder. It knows something's off, but it can't quite assign it to a cylinder.
Now,
It could be a lot of things.
Yeah, and first of all, misfire, Pierre. Misfires can be many, many things. Now,
Right.
the number one thing, what do you guys think the number one thing is when someone hears the word misfire?
What they think. Should we wait for them to answer it?
They think it's spark related, right?
Yeah. But what about mechanical?
What about fuel?
Right.
What about something like EGR possibly causing it, right?
Right. Or a purge problem that somehow didn't get caught because it hasn't run the purge test
Or
yet.
the AIR system, air injection reaction system.
Right.
These are all things that can cause a misfire, and they all need to be looked at. You know, I always write about, and I just finished my article that's due tomorrow, the Motor Age. Actually, I just finished it this morning. And when you look at it, you always have to have a game plan. I'm always writing about the game plan. Well, if you're the sucky Giants and Jets, well, they won this past weekend, but, you know, how good are they? You know what I'm saying? They're not good. So anyway, we won't even go there. That's how bad they are. But here you can see we have a random misfire. It could be any of those things. We have, look at this. This is interesting. You got a short-term fuel trim minus 24 on one bank, minus 2 on the other one, but long-term fuel trims are only 0.7 on both banks. Now, what would cause something from taking away, a command to take away fuel? We could have some sort of rich condition going on there.
Or we could have something like a bad oxy sensor ground floating the signal just a little bit so the computer thinks it's got too much and it pulls away fuel, and you end up with a lean misfire.
That's right.
You can put 27 spark plugs in it. It's not going to fix it.
Oh, come on. It's a new spark plug. Good,
Okay,
good.
36.
36. All right. Now here, this looks like a library system here where
Yeah.
you got a whole bunch of DTCs. Now, Misfire, this is one of Pierre's favorite cars, a BMW. And it tells you low fuel, Misfire 313. Now, this is something I've noticed on European cars. I know I've had stuff like this, like on Audi and stuff. They'll code for low fuel. Because if you're going around a turn and, you know, you got a wild ass M BMW or an S series Audi or
a lot of
something,
G-forces to the side in the
bet.
suspension. You could be sloshing that fuel away from the pickup, and it could be trying to pump air into those injectors.
And when this guy was a little younger,
A lot younger.
he would really give you a good ride for your money, as well as myself here. You know, you calm down as you get older. We would make it from here to Massachusetts like man.
Very quickly.
super
We're
quick.
on air, so we're not going to tell you the time, but it was quick.
Yeah, someone may come give me a ticket or something. Now, look at this. On this Misfire, we do have system lean, bank 1 and bank 2. So this is an important thing. And again, your game plan, do you have something to check if the system's really lean or rich? And what am I alluding to?
So originally, I would have said an exhaust analyzer, and that's still a very, very viable thing. But nowadays, you can buy an air-fuel ratio sensor with a box that you plug in a cigarette lighter. It's not as good as an exhaust analyzer, you know, overall,
Right, gives you some
but
sort
it
of
tells you
idea.
whether you got lambda or not coming out the tailpipe.
Right.
Very
And-
important.
And by the way, a lot of FRC cars, freaking race cars, they would use a lambda sensor.
Yeah. In
like
fact, a
that
lot of
sort.
this technology, that's exactly what it was really made
Yeah.
for. Race cars, but it can be used for diagnostics.
That's true. Okay, so here a Mercedes with a misfire. So you can see, just looking at scan data is the first place to start after again, speaking to the customer. Use the brain, the eyes, the ears, the nose, the hands, because you may hear something, you may see something, you may smell something.
And don't be afraid to ask them questions like, did this just happen once? Is it only under certain circumstances? You know, you don't have to be like accusatorial, but the point is, try to figure out what the environment is. So
It
you
can't be
don't.
Detective Columbo. Just
No.
one more thing. One more thing.
Yes.
So, you know, maybe was it raining out? Was it snowing? Yeah.
Was it only on left turns? Was it only after they stomped on the gas and hit the brakes hard?
Was it
Whatever.
significant other sitting in the car with you? Well, I don't know.
Which, by the way, that sounds crazy, but there have been some cases
That's right.
where the computer was under the seat, and it didn't matter who was sitting in that other seat.
Well, we want to blame the significant other.
Of course we
It's
do.
always better.
But the point is, whatever that weight was on the seat was banging on the computer. and hitting the connector, maybe,
And
whatever.
you know that Mountain Dew or that Pepsi or Coke that you were drinking that you spilled? Well, it doesn't do real good in that computer. Okay.
Or
So-
anything else electrical.
So here, even on something like the Zeus, you could see we have, look at Misfire histories, okay? And this is off a GM vehicle, as you can see. But look at this. You got how many Misfire history cylinder 6?
52,000 and change.
You think you may have a problem there? Maybe, right? So scan data, and what else do we use a lot? Now, if you're not using mode 6, shame on you.
Actually, you're missing a gigantic clue.
Definitely.
And also a very important aid when you think you've fixed the car,
That's right.
but you're not quite sure. Do you give that car back to the customer and say, drive it for 80 miles till the monitors all run again? Wouldn't it be nice to know that you don't have a big problem already flagging?
Yeah, you know that you suck when they come in on
Yeah.
Friday night.
And with the light
Because
on.
They only know about the light. They don't know what that code was, right? This is why you see these screenshots. These are real vehicles that we actually capture for customers. We either text them, email them, or print them out in full color for the simple reason we want to show them, here's what we found. Now, when you get to mode 6, there's a few things. Here you're seeing a Ford, and I can tell you that this is a non-CAN vehicle. How do I know that? You do not have a long list. This does not slide down anymore. And Ford was generous with giving you misfires right here. For example, when we look at this misfire right here, you're going to see we have cylinder number 1. You have a test value of 4.379. The maximum is 3.931. Okay. And I can blow that up even a little more here for you.
And they call that a percentage. So that doesn't necessarily mean that is the actual misfire count.
Very
It
good.
means that the number, that's the flag, that the point you're not supposed to cross is below the number that it actually crossed.
All right. So now the other thing I also want to bring up, you may not know this, but there are only 2 scan tools out there that read, update mode 6 continuously. What do I mean by that? Well, here's what usually happens on most scan tools. Now, misfires usually will count up. We've done that in here on a few webinars with different scan tools. But other scan tools that do not have this right here, you see read mode 6 continuously, you have to select that. And what this is really doing is this. Rather than just one shot, okay, it's going, give me the update, give me the update, give me the update. Now, it may not update because what do we know about mode 6? Mode 6, most of the time, you got to drive the vehicle. You got to
That's
meet
right.
the criteria.
And you got to run through all the different test criteria for whatever monitor you're actually concerned about.
Now, you know, another thing when we talk about mode 6, like this other screenshot, and by the way, you see this has more info on this one, and we're looking at different percentages. Can't see it?
No, where do you want? You want this one?
Oh, don't worry. Go to me. We have Doreen behind the board. She's like, where do I want it? I don't care where you want it. I got to talk to them and explain. So mode 6 could be very useful if you use it correctly. Now, when you're going down the road with stuff and you don't have something that's doing this, you're going to have to back out of mode 6 and go in. So either Auto Ingenuity, that's right, Auto Ingenuity, or eScan are the only 2 that I currently know out there that do it. OTC used to do it, OTC Bosch. I don't know if there's.
I want to add something here that has nothing to do with the actual scan tool, but it has a lot to do with how you interpret stuff. This says it's a Ford. What if this is it's a Mitsubishi that's licensed to Chrysler?
Let's get the holy water out.
So I'm using that as an example.
What a
The
bad-
point is that if you put Chrysler in, it might not interpret the data. You might have to put Mitsubishi in. So whenever you get one of these cross-licensed not hybrid, but kind of, I call them hybridized. You know, these
like a Chrysler Crossfire.
like a
which was
Chrysler
Mercedes
Crossfire, which was a Mercedes or Daimler. So the point is, just be aware if you pull one of these up someday, and it's going to happen, and this stuff comes up all as hexadecimal and it doesn't know what it is, try to pick the other brand. If it's one of those cross-licensed brands, doesn't matter what scan tool you're using, got to pick the other one.
Yeah, no doubt, no doubt. So here is something on the Ford IDS, and in Toolbox right here, when you select this, you can do the Misfire monitor. And notice it does these little graph lines here. The blue is what's happening the most because it's writing itself, and that's the latest. But look at this. There are no Misfire counts. Zippo. That is telling you we don't have a problem.
And if it had misfires, it would show you the grays, you know,
Being
a
higher or lower.
bigger and bigger range of errors. Yeah.
Right. How many of you out there are actually using the Ford IDS? It's a great tool.
Fantastic.
Super great tool. Got a lot of good stuff in it.
Yeah.
Now,
Yeah, there you
here's-
go.
Yeah, look at this on a power balance test. You can see, doesn't take, it's not rocket science. Look at this. We have something going on number 6 cylinder. Okay. And then you could erase it as this little erase thing. You can rerun the test and see what's going on. So these are all things that I would highly suggest that you utilize for testing misfires, because it's all about ignition, isn't it?
Yeah, that's what a lot of people think. You know, I've put 3 sets of coils in it. That other brand of coil must have been no good because it still doesn't work. But they never did a relative compression, and they never checked the mixture.
Yeah. Question there, Doreen?
No, Pete said it's better when we focus in on that rather than the slides.
Oh, okay. Well, hey, whatever Pete says. Now, a gas analyzer, and Pete, you could butt in anytime you want. You know, I want to make sure.
I heard that. I heard that.
Now, an emission gas analyzer is super important. Really is. I mean, when you're looking at stuff like this, first of all, there are 3 failing gases: hydrocarbons, which is raw fuel; CO, the stuff that'll kill you, carbon monoxide; and oxides of nitrogen, NOx. I personally don't care about them. And, you know, a lot of people think, well, you know, it's going to fail an emission test. I'm not worried about that. I'm worried about how the engine is breathing and how it is actually burning the fuel. You know, when you're on a gas engine, what's it, 25, 28% efficient?
Maybe.
Maybe.
They have some experimental ones that are over 30.
Right. But let's say 20%. So we do easy math. That means you got 80% that's not being used and burned.
Well, it's going out the
Going
tailpipe,
out the tailpipe.
but it is not giving you power. That's it.
We
Nope.
didn't even rehearse that.
No, that's just,
we just
yeah.
So here's what I would like you to really go after. O2. Oxygen, the amount of air we breathe, 19 to 21% in this particular room or where you are. But if I don't use up all the oxygen, and, you know, Pierre and I both remember Euro cars had a little tube where we would put our gas analyzer
Right in the manifold, right after the motor.
I wish it still had. I wish
Me
that was a
too.
law.
That is such a good feature.
Used to set up fuel distributors in the old days, of fuel distributors,
Or carburetors, before
carburetors.
that.
and you really got a good sense of what the engine was doing.
Of course, we had whopping 2 gas analyzers back then,
Okay?
but we
Or-
still were able to,
To use it.
or a cheap air fuel ratio sensor, right? I mean, not like today's. Really,
My old Sun machine, the first one I had an air fuel ratio.
yeah, that's right. Yeah, that was
Then
the
he
old one.
went to HCCO, and then if you had money, you got the 4 gas.
Yeah, that's right. That
Then
was
we
the
went
big.
5 gas.
That was the big deal. Right?
So O2, the amount of oxygen is important because ignition is going to give us a high oxygen content. Why? Because the motor is nothing more than what, Pierre?
The motor's an air pump.
An air pump. I
And
can
if
blow
you're-
up my balloons and stuff with it.
I guess you
The
could.
kids' raft or the kids' pool. Sure, I can. Sure.
Yeah, of course, it would have a little carbon monoxide and hydrocarbons
Well, hey,
and stuff in
I'm
it.
not responsible for what happens to the kids. So,
Bottom line is, you want O2 to be as low as possible.
exactly.
0 probably means your machine is broken. I mean, you did something, got something
Or
wrong.
you're super duper rich. This is
Or
why.
you're extremely rich and then it's very close to zero. It's not really zero.
Not
It's
really
0.00.
zero, but very close.
Yeah, rich mixtures burn all the oxygen, use all the oxygen up. Lean mixtures do not.
Correct. But here is the other thing I like, CO2. Now, for all the green tree people out there, this has become an evil gas. But for me, I care about this is combustion efficiency.
Yeah.
The higher the number. So you see Pierre's example, close to zero with O2. Well, combustion efficiency would be very low. You may be down to 9 or 10 or something even lower. Well, if we add, let's say, no more than about 0.5% oxygen, you'll be up at 14 or a little more.
That's right. And then you're going to 14% of CO2, that is.
CO2, correct.
And above. And then you've got a nice, efficient running engine.
Very nice. That's a good running mode. So Lambda is basically taking the 5 gases here that we see and coming up with Lambda, which is roughly 0.97 to 1. Okay. So a perfect one to make life easy. 1 is good. What happens, Pierre, if I'm above 1? I got 1.3.
1.3 is 1.3 is 30% lean.
Lean, hold it. I always told the high number was rich.
Oh, that was an oxy sensor.
See, this guy knows his stuff. He's a gas man.
I'm a gas guy.
But that's from
Well, that's from age, you know. So
I'll give you some tongue.
that's it. Bottom line with Lambda, higher numbers are lean, and it's a direct proportion. It's a percentage. Lower numbers are rich. So 0.9 would be 10% rich.
You know, how many of you are using gas analyzers out there? Can you type in the number 1? Type in the number 1 so we can kind of get a feel for that. And if you think it's only, I remember teaching out in Hawaii and down in Florida, you know, they don't have emission programs. And right away, when I hear you talk about a gas analyzer, we don't need that junk. Go, dude.
Yes, you do.
I'm not talking about for emission tests. I don't care about that.
And by the way, while he's talking about that, how about you guys say in California with your smog stations and you don't even use it for diagnostics?
That's
Please,
a sin.
you have it in the shop. Use it for diagnostic. Use it for a nose start, a crank nose start. Put it in the tailpipe.
You bet. We got a couple of people ones. Your
Good.
fingers work. Thank you so much. We really
And
appreciate
it's a good thing you people are using exhaust analyzers. Right. It's a very important tool, underutilized in the industry.
You bet. Now, here's another problem, Pierre. So we talked about, you know, we always start with a good battery. We want to make sure you got all your fluids full in the car from engine oil and everywhere else. But once you check the battery starter alternator, you need to check mechanical. And our old Sun machines, because we're both Sun guys, right?
Yeah.
We always ran these tests that would tell you what I just said, battery starter alternator.
And they ran you through them one at a time.
Then it always went to mechanical. Remember we cut the cylinders out with the
That's
buttons?
right. You had the buttons.
White and black buttons. Okay.
That's
I
right.
thought it was ebony and ivory. You know, it turned into McCartney for a second.
The bottom line is this. This doesn't show you, a relative compression test doesn't show you every possible thing that's wrong with the car. But if it fails this, you better not be chasing ignition or fuel injectors because you have a mechanical problem.
You bet. And by the way, this is why 2 major manufacturers, 2, not 1, Ford and Toyota Motor Company, both use relative compression. Now, you have MDS like on Chrysler products, multi-displacement system that cuts out 4 cylinders. You got DOD, displacement on demand, like GM. It doesn't work all that well on those, but it's better than doing nothing. And what you're really looking at here, let me do this. This is basically showing you voltage drop. Let's concentrate here right up top. Notice your battery voltage went down to a minimum of 9.9. We were up here at 10.3, and we were cranking along for not even a long period of time. It usually does it, in 10 seconds, I think? 10?
Yeah. It's actually probably done it in 5 or 6 seconds is really when it's done.
You know what thing I want to bring up here? I seen Jeff answer this question. How do people do it with a push button because you can't crank it with the key?
Okay. So.
Turn up your mic, G.
My mic is up. I'm up.
Oh.
Is it not loud enough?
Should I scream more?
Yeah.
Okay.
And I got a question. What if the injector is open and wash a cylinder on RC test?
Okay, so what if the injector is open, meaning it's putting out a lot of fuel, and it washes down the cylinder, what would happen on a relative compression test? Well, possibly nothing, or
But
possibly
a
something.
loss of compression a lot of times. However, you would right then and there know that you have a problem with compression. That doesn't mean tear the motor apart. That means find out why you have a compression problem. You should be doing those other tests. If you had an exhaust analyzer right after that, you would see monstrous error. In fact, at that point, if you had you'd have a misfire from that, especially on a startup.
Right.
You'd probably be able to sniff a gigantic amount of hydrocarbons from the dipstick tube.
But remember, this is not 100%.
This is one piece.
It's probably somewhere about 90-ish, but being about 90-ish, okay, there's always a chance of error. But I would definitely run this. So when you're looking at voltage drop, and I don't like to go on the 10-1 on today's new vehicles, 960 older ones. Why? We have a lot of electronics and these batteries. And by the way, if you go with an AGM battery, it's not like the old lead acid of 12.6, 2.1 volts per cell. Okay. It is about 12.8 of open circuit voltage. So they have a little bit more, like 2 to 3 tenths more in an AGM battery. So, I didn't know this recently. A student of mine said, hey, gee, and I contacted a battery manufacturer. Don't know what you don't know. And I thanked my student for making me aware of that. He said he read something, in an SAE magazine, and sure as hey, I must have missed that. He was right. So we learn something new every day, and I don't know everything, nor does Pierre. But you add our experience together.
And by the way,
know
networking in the industry is very good for that
You
too.
bet.
Whether it's an online group or some just local group or the guy in the bay next to you who knows a lot, whatever it is, networking is important. So I think the important thing to take away from this is this does not say the engine's perfect and you move on automatically, completely. It says, I don't see a big problem right now, and I'm going to go look at other things. If it was bad, however, you have to chase the mechanical gremlin first.
But here, I want to bring something else up. Who has seen this? Switch to the slide for a second. Let them stare at the slide. And when I blow this up on a slide, they can see it through there, correct?
No.
They don't.
Blacks out.
It blacks out?
Yep.
Ah, not good. So
I
they
was
can't.
trying to tell you before.
Oh, it's not good. So they don't see. They only can see this.
Yes,
Okay.
and this
So
is better.
here's what I want you to look at. What do you notice here? It's telling you battery voltage low before we do the test. So battery voltage is low before we do the test. Always start with a good battery. Always do that. If your battery is bad, come on.
The whole test is bad.
You don't want to go on the 12.45 volts. That's bad.
And by the way, a test like this, which is using the battery power and the starter motor to see how much each pull is, doesn't work if you have a charger on it.
Oh, come on.
You could use,
Why would that matter?
because you're introducing electrical noise. You're corrupting this test. You're ruining it, actually. If you have a bad battery, you could put a jump pack not being charged, just a jump pack on it to add to the battery potential.
It's
but
way better to
have a good
charge
battery.
the battery up first or put another battery in.
right.
We stock a lot of batteries here. Sometimes if a car's where the vehicle is not, let's say, the greatest,
It's a beater, in other
it's
words.
a beater and a guy, doesn't want to spend a lot. We're going to take one of the batteries off the rack, throw it in there real quick, and make sure we are getting a validated test. That's the important thing that
Yep.
we want to get here.
Okay.
Now, look at this. We're using our lab scope, and on our lab scope, do we see any issue here? Now,
Yeah.
Pierre, what can you pick out here? How am I performing this test?
Well, it looks like it's. First of all, I can't see the thing on. Is it amperage? It's very low numbers.
So it's
But-
on CVVV,
It's volts. Okay, so it's voltage fluctuations,
and
and we've got it on 0 volts, which that doesn't sound right.
well, we have this AC coupled.
We're only AC.
AC goes above and below 0. So AC coupling the scope, we see it go below. You see here 0, we're under and over. And right away, it's playing the odd man out game. You see how my finger fits here? I always like using my finger. Okay. I can see that this don't look the same. It's not rocket science. This can give us a misfire.
That's right. Now, I'm going to say something here. I don't like the words AC coupled. I'd like you to think of it more as DC filtering. It ignores the DC and only shows the AC part of it. You got to, maybe I'm
okay with that.
picking nits, but the bottom line is there's a lot of what I call hair here, and that's all kind of electrical noise. As long as it's consistent, the same for every pull, it's good. And if there's a lot of ripple, an odd guy like that, that can cause trouble.
Now, this is most likely filtered as well. You go into Snap-on. How many of you have Snap-on? Type in the letter S. If you go into channel 1 and you select AC coupled and you select filtered, you're going to get a cleaner signal. Now, this has been like that. Now, if you want to use your amp clamp, now we're talking about some beautiful lines.
Well, that's actually my favorite method.
Okay. But here's the problem with the amp clamp. Oh, someone left it on and the battery's dead.
I do that all the time. Okay. I carry 2 or 3 spare 9-volt batteries.
But, when we ran out of 9-volt batteries just recently, I'm like, later for that. Normally I just AC couple it because all I want to see is the odd man out game. And like this is a problem versus, look at this. Before the repair, after the repair. It's not that hard. Not that hard. Now, here is misfire counts on this Chrysler product. You see, we have 44 counts, but you can get up to 65,535. Okay. And here we have something that we're going to be using tonight. Mac Vanderbrink, the father of the Allen Smart Scope and Bear machine, he used this thing here called the ECOP. He invented it.
No, that was the COP 3. COP 3.
Oh, COP, excuse me.
Yeah, we're going to use an ECOP as well.
I misspoke. COP, I'm lucky I'm looking at it. COP 3. You probably don't have one of these, but if you did, it works real well. And we'll explain that because we're going to go on the vehicle. And I'm using my Fluke 196 lab scope here. Not only am I picking up an ignition signal, and I'll blow that up there for you, but I can tell you on this superimposed signal, we can see here's my firing line going up, and this is my spark line, and you see some of the jaggies, as Mac Vanderbrink would call it. That right there on the spark line, okay, is not good. That means I got a misfire going on. Here are coil oscillations that need to be at least a couple of them on a vehicle.
They used to say 3 was a minimum, but nowadays with modern engines, it could be 1.5 or whatever. They've become more efficient.
And here, as I was doing a class, we used the 192 lab scope here from Fluke, and we see our dwell time looks like almost like a fuel injector. From here to here is the electronic closing. And dwell is the amount of time the coil is saturating. Then this is the firing line, a straight line up. Now you see here, the misfires right in there. There's the spark line. And look at these coil oscillations. They're pretty good, aren't they?
There's a lot of reserve energy left over at the end. By the way, dwell, that we used to call dwell, on modern engines is computer controlled. It's not.
Right. It is computer controlled. And here's another tidbit. You could have a vehicle, when you race it up, this should always go that way. If it doesn't advance, you got an ignition problem going on there. It could be, if it was an old day of a module, could be a module problem. If it's something computerized, could be something in the computerization. Okay. And here we have the modus where this here is showing us that we also have issues going on. And again, if you just look here, doesn't that look like a fuel injector? Yeah. But here's what I want you to concentrate on the actual spark line, not the firing line, is that. Spark line is here. You see this? That is an actual misfire going on. And we're going to show you different ways to pick the pepper out of the fly do just in a minute. Now, we did say we were going to show you voltage and amperage. Now, caution, caution, caution. If you're using your lab scope to be an ignition scope, secondary ignition voltage could exceed 35,000+ volts. So when you see 35K, that's minimal. That's an old system. Most systems you're working on are going to be like 40 up to near 100. A lot of coil-on plugs, they're going to be banging them out somewhere about 80,000. So if you have your little shielded metal piece going to your scope and you lost the ground, the voltage is going to come right through that arcing plug, wire, coil, whatever.
And smoke the scope.
Smoke the scope. Now, I can tell you over the years, doing classes for Snap-on, doing stuff with Fluke, Fluke always had, you can put an extra ground in the top of them, okay? But if you didn't do that, you're going to burn the scope out.
And funny story, I had a Fluke, but
It's a Fluke.
and I was doing a test on ignition, but it was a race car, very noisy, lot of vibration. And I heard a noise and the car died. And it turned out that my ground clip had snapped off with all the vibration, didn't smoke the scope, it smoked the ignition module in the car. So that can happen too.
Yeah. By the way, this is what I'm looking or speaking about. Can you come in on this metal clip? So this would go around a wire. Make believe it's a spark plug wire. Okay. And if this piece caught this wire arcing and you lost the ground, it'll go right into the scope and burn it out.
Go through the scope ground.
Right through the scope ground.
And take out the circuitry.
So be very careful. And by the way, if you had one of these and you wanted to do a coil-on-plug, does anyone know the trick out there that you can do if you don't own all those fancy looking things? Let's see if anyone knows. Type that in there, and Pierre, remind me to speak.
To ask, right. Okay.
I will give them the answer.
Now this is current. So this is the voltage signature coming to ground, which means the coil's being turned on, releasing. By the way, you see that little blip up there? The module that was controlling it decided it was saturated enough. You'll see some of these that's pulled the ground and then go up very early. They don't want to overcook the coil. They've figured out that it's saturated. And then it releases. The spark begins, well, technically at something called a point of plasma, but close enough to that. And then you can read your ignition event. In this case, that looks pretty healthy there.
Correct. Now, you know what's unhealthy right here on the spark line? If this line is on an upward angle, that is going to indicate a misfire, like a lean condition or a wide gap. Now, there's plenty of other things, but this is the quick, easy way to think of it. If you see this right here, angled up, let's blow that up. If it's angled up, you got either a wide gap, okay? So rather than it being like this on a little slope, you're up like this more, open gap or lean condition. If it's down on a downward type spike, then that would indicate a closed gap or very rich condition. And you can see the coil oscillations here. 1, 2, 3, going down.
That was it.
That's usually a normal plug.
That's
now,
considered textbook.
here is the other thing. That is textbook. And here is the other thing here. As voltage, you get that up there. As voltage goes down, the point of it going down, look at this, amperage goes up. And right here in the dwell time is current rampant. If you don't get something on a coil, and this is why this is important to do both. If you see something going up high like this, not ramping,
You got a short.
you got a problem. Because here, Pierre, wouldn't you say that's roughly about 7.25 amps? Roughly?
Yep.
So
That's it. Hair
that's
over
what
7.
you need to do. How many of you out there do that? If you're not doing that, you may not really be looking at ignition carefully.
Now, by the way, most cars have a relay or a fuse, something that feeds all the coils, often all the injectors, pre-GDI that is.
Correct.
And if you can put a fuse buddy in that fuse or one of those relay adapters in the relay with wires on it, you can put an amp clamp around it and you will see all 4 or 6 or 8 injectors, all 4 or 6 or 8 coils on one waveform. You can see if they're all the same as each other.
That's a very good tip.
Fast
and
test.
A good way to check them all at once. So here again, another example. As voltage goes down, well, look at our amperage. See, we're at 0 there. We're pulling up. And how much amperage Did that coil pull? Well, I'm 500 millivolts per division. Right here is 0. That'd be 5 amps. We're roughly, I'm going to say about 8.5 amps or so, give or take. And look at that nice spark line there. Okay. And there's our coil oscillations again. That is a healthy ignition signal. Okay. Any questions out there? Now, we got something similar to that. Does anyone know what this is behind me? No, it's not a bunch of pyramids, okay? It is what? What is this? Come on, you guys were chatting online before. Well, you got ignition, because that's what we're doing. That's our yellow.
But it's happening 3 times. What is that?
And look at our amperage. You see the green and amperage as voltage goes down is yellow. Okay, there's the firing line. But look at this amperage. We're roughly a 7 amp or so coil. This is called multi-strike.
And in fact, the car we have tonight has that.
You're going to see it. Now, BMW, and someone answered that. Very good. Thank you so much.
And by the way, at least on the BMW, this isn't a universal strategy, but it only does the multi-strike on the ignition at idle.
This is the same thing Ford does. Only at idle. If you race it up, you will not see 3. This is all for emission. How many of you remember the Nissan system called the NAPSI system? The NAPSI system used 8 plugs on a 4-cylinder and had a multi-stage distributor cap that had a high-end rototip and a low-end rototip. This was so they could fire all of these things. Well, this is done electronically. They're going in there, they're firing that thing and giving it an extra couple of shots to try to burn up those unburned hydrocarbons.
And you know what? It also makes it idle smoother.
It
It
does.
smooths it out, but it's there for
you're gonna see
emissions.
it. We're going to be on the scope just in a bit. We want to get a lot of this stuff out of the way. Now, here's another big issue. Rodent problems. You see this here? You see how this is chewed up? This is a misfire that some people couldn't find. This came from another shop. It's a guy Pierre and I both know.
Yeah.
He had a misfire, and to be honest with you, this was on a hybrid vehicle. Well, when your engine is not running well, guess what? The ice does what? The ice is basically the gas engine, and it will help the regen system work. But if it's not running correctly, it goes into a strategy and you got a problem. So this little rodent that went in here and, you know, huffed and puffed till it blew the little house down per se, okay, it needed to be fixed. So what did we do? We cut the wires back, soldered, I should say, and heat shrink them. We used the solder in the heat shrink. And when we're done, we're going to use peppermint oil. So if you don't use peppermint oil, now if you worked for Honda, you would know they have a part number for this stuff. And peppermint oil keeps away rodents.
Rodents don't like it. I like rodents. It's guaranteed employment. I made a lot of money from them over the years.
And by the way, why do they like eating wires
Well,
or chewing on them?
somebody decided, for some reason I just can't fathom, that they could make soy-based insulation for wiring. Let's
know
make
why.
a food-based wiring insulation. There you go, peppermint oil.
Here's our peppermint oil that we get. And I don't know who this company is, but this is stuff we buy, and I have a big gallon over there. We load it up. You know, I spray my vet down before it goes away for the winter, which is just about now.
Actually, I saw them spreading
We got a
salt.
question or a comment?
So, Mr. G, how come Nissan went back to something similar to what you were speaking about? They're using 8 injectors on a 4-cylinder engine. I wonder why they are using.
Oh, very good.
Do you
Okay.
know?
So someone asked the question, in case you couldn't hear Doreen, why did Nissan go back to something I was talking about? I was talking about ignition, but 8 injectors on a 4-banger. They're not the only company.
That's actually going to be more prevalent soon.
There's a big problem with carbon buildup. So you have 8 injectors, 4 conventional that you're used to, and 4 GDI. Well, they thought that GDI, gasoline direct injection, was going to keep the valves cleaner, Pierre.
And it was going to run better, longer, all of that.
You know, I guess they didn't figure it out too well. So you remember the days, and we had these, the cold start valves on the European cars, when you didn't let that valve go. Now, some of the strategies were they shot the cold start valve, not only when the engine was cold, but to help clean some stuff up.
Right.
It was like an extra spray. Now, all of these cars, even the brand new C8 Corvette, you're going to have 16 injectors on that 8-cylinder, 4 regular and 4 GDI. The reason is to clean it up. So good question. And by the way, there's a real neat strategy with that. They're not going to just use all GDI when you want pedal to the metal. They may use a mixture.
Yeah. And actually, they're doing it because there's all kinds of science about stratification and homogeneous charges and yada, 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 which we don't really have to get into tonight. But the point is, they've done a lot of engineering to make these systems as efficient and clean as possible.
Right. Now, the old days we used walnut shell blasting. I winded
Pain
up,
in the neck.
yeah, I winded up throwing my away. And
I still got mine.
Got to be careful leaving any walnuts behind on modern motors. You may cause some damage there. You really need to make sure you vacuum everything out very carefully. Now, the 3C machine, not a commercial, but we have it here and use it very successfully. You got to clean the machine out, but that works real well.
And like any powerful tool, you have to read the instructions and follow them carefully.
TFI. Yep, you really need to do. Another comment or
Well,
question?
we just comment. They said dryer sheets work similar to the.
Okay, dryer sheets are another good thing. Some of those will be going in my RV besides peppermint. Now, grandma's mothballs work very well. I have that under my trucks outside because I don't care what the trucks smell like. Okay, but it keeps the rodents away quite a while. Where peppermint spray, you probably got to bang it out about, I'd say, every 3 weeks or so.
I was
Same
going to
with
say
dryer
a month,
sheets.
but yeah, that's right.
Yeah.
Every month, at
Yeah,
least.
I just sprayed next to my car, even though it's not away for the winter. Rodents, when it gets a little chilly out, like up here, it's not like peat land
And-
down there.
A cat works too, but not 100%.
Yeah. And by the way, speaking of cats, because I take care of feral cats, please do not use peppermint oil around your domestic animals, your pets, your dogs, your birds. If you have a snake, I don't need to know that stuff. Send it to Pete with his alligators down there. Okay. So here, that was the repair on this thing. Now, when you want to load a circuit, Pierre spoke about modules. So you see these coils on this GM setup here? Now, GM had this little test to use your test light. Take the coil off to see if the driver of the module is good. Clamp the black clamp on one end after you baselined your test light, meaning you went to the battery, negative and positive, it lit up. Then you take the other side, and when Bob cranks it over, hey, Bob, crank it. You've seen the light flash. It said the module was good. That is a big lie. Why? What's the difference?
It's an invalid test. There's no current going through that thing.
Well, very little.
Very
It's
little.
only,
Well,
it's
okay,
only
yeah.
about 200, 300 milliamps.
That's nothing to me.
That's
That's
peanuts.
no current.
We need a coil. We need a load that can do 5-6 amps here on this coil.
Right.
So this is a way to load the circuit up. And many of you probably do that.
I have a headlight, by the way, mounted right on my toolbox with 2 wires soldered on it with clips on it.
We got a headlight
Yeah,
over there,
right.
right there.
Cheap
The
tool.
same headlight.
Same headlight. Yeah.
That's right. It's
Yeah.
right over there.
Yeah. There you go.
I got to go grab it.
Yeah.
See it staring me in
The bottom line is these are old school tools. Don't cost you really anything. I mean, you could take it out of a junk car.
Now, I
There
got a
you go.
bigger one upstairs. If you get one of the old 6014s, now that's more current flow, but you can load it up. You see, we have some pigtails on them and stuff.
Yep.
It's a real good thing.
It's a valid tool.
Yep. Question or comment? Come on,
Well,
little
we got
fly.
the vet, the RV. Tell us about the boat.
The boat the ex-wife got. Okay.
So no boat. It sank.
No boat, no jet ski. Those were the days.
That's
Those
right.
days are over. We're going to use this tonight. This is a cop. No, this is a GTC 505. Keep calling it a cop. This tool, I really love it. Daniel up there from GTC, General Technology Corporation. It can show you the spark line, but here's what I really like, and we're going to show you this tonight. Not only the the picture of your ignition that you can check real easy. But look at this. You can compare cylinders, and we're going to do this on this BMW we have in here. So we got more in store on car for you, so we won't bore you just speaking, but
There it is.
Look.
By the way, this is a very handy tool. It's not as powerful as an oscilloscope, but it's a quick tool. It's a, it's a kind of a sanity check.
See this little wand? You stick it next to my head, something goes on.
Yeah, right. Yeah.
It makes a
And
signal.
if it shows a signal, then he's got an arc going on or something.
Hey, I'm not Tesla.
There you go.
We've seen Pete use the Pico scope, and Pico does a very nice job. You can see when you're in, KV, you do need to be careful using your Pico scope with an attenuator. If you don't do that and the voltage is very high, you can run into a problem. Okay, so we don't want anyone to have an issue with their scope and burn something up.
And by the way, this is always a calculation, the KV. It's not measuring actual KV.
That is correct.
This is true of the old big box scopes years ago. It's true of anything modern. Just be aware, it's more important for it to be the same on every cylinder on an engine, on one car, than it is for it to be at some number that you read out of a textbook.
Right. And by the way, the old days, it would be like 10, no more than 12 thousandths.
At idle.
If you had more than that at an idle.
Actually, 8 to 9 was
Right.
not an unusual thing. And then when you snapped it, you might have 18 or 20 or
But nowadays, what do you see? Because of lean mixtures, you're going to
35,
be up
40, 60.
there, no, but just running. You're going to see
Oh, yeah.
about 12, 15 is normal.
Just sitting at idle.
Sitting at idle.
But when you snap it and it runs a little lean, it goes way up.
Way up. What do we have? You got a question? Or?
Hey, I just want to interject something real quick there to what Pierre was just saying, if it's okay.
Sure.
All right. As far as the scope goes, I want to make sure that we didn't confuse anybody by accident. What Pierre, I think, is referring to is the fact that your multimeter, your digital multimeter, your digital scope are all digital tools. They don't read directly like the old analog tools did, whether it was a multimeter or an analog scope that was plugged in. What you're doing is you're sampling whatever that input is. In the case of a scope, millions of times per second, and then your tool is plotting that information out on a graph format where you can see it. If you're using a multimeter, then it's the average of those samples that it's displaying. So that's what I think we want to make sure we keep in mind. And as Pierre very aptly said, I'm not too interested in having an exact number that firing KV. What I'm looking for is uniformity among the cylinders. So just my 2 cents there, guys.
Pete, that is very good. Thank you for adding that. And by the way, jump in at any time. You can step on me whenever you want. Don't crush me on the butt.
Wouldn't do it. I'm just
Okay,
watching the chat and saying,
Okay. Here we have a good ignition system off a Hyundai. And you can see, there's a decent spark line, but look at the red one. The red coil, this was 2 different cylinders. The red one is flatline. We're using the E scope with an E cop. And the second coil here was bad. And that's the way you can do some of these things. We're going to be using an E cop tonight, even though this system is not technically a coil-on-plug per thing.
Oh, this is a coil-on-plug. The problem is
deep
that the coil is nowhere near where we can test it. Yeah. The electrical connector's up top, and so you can't actually put any kind of a sensing system next to it, next to the actual coil. You can't get close enough. So the signal's a little. And by the way, this is true of a lot of modern cars. Not only that, a lot of modern coils are heavily shielded, so that you won't get all of this electrical noise or radio frequency noise. They're trying to shield it so other components in the car don't get kind of polluted by it, but it makes it hard to test.
Oh, so when I'm driving down the road and I step on a pedal, you am I
Yeah,
radio?
right. Yeah. That's exactly what they don't want. Or worse yet, they don't want that electrical noise to make the computer think something's happening that's not even happening.
Right. And remember the old days before resistor plugs.
Oh, they used to be very
and
noisy.
Resistor wires. You had a lot of noise in your radio.
You could almost tell if the car needed a tune-up just by putting on the AM radio.
That's right. You check that frequency out. And it wasn't WABC.
No, it was more like a type of thing.
Are there any questions? Are we still going? We're good? Okay. Now, look at this. When you take a plug out like that, Well,
Oh,
I think we got a little bit of a misfire going on, right?
so now there's no gap visible there, right? But what that really is the insulator has broken and it's up against the ground electrode. That's all bad news
It's
there.
not going to work too well. Now here, just like we have here, I do want to speak about this. Now you can see my old AC. You know what AC stands for? Albert Champion. Okay, the Champion brothers. They broke away from each other. Can you see that, or you can't?
Yep, sorry.
Okay. But this was the thing we used with the ground clip. We would clip this on to a ground, put the wire here, and if it actually, there we go. So you would clip the ground, and if it jumped the gap right here, there's no electrode in there, then it was said that you had good spark, Pierre.
Oh, yeah, you had a good coil. Everything was good. Well,
This is like your father's Oldsmobile, okay? They're out of business. Your butt's going to be out of business if you're doing it this way. It'd be like, okay, Pierre, do you see the spark? You can't go by that.
no.
Now, here's what you need. It's pictured up here, and notice we have this out about 40 thousandths, but when you unscrew this all the way,
40 kV.
yeah, 40,000, 40 kV. So when you screw this all the way out, past the 40 thousandths, any second now. So here's what we do on a coil-on-plug. If I can jump this, and if you look at the gap, you're roughly right here with it all the way open.
Yep.
Okay, I'm all the way at the end. You jump that gap,
That coil is good.
you got a good coil.
And the power to that coil is good. And the ground turning it on is good. Everything's good.
Do not open circuit. A lot of people, what they do, they open circuit, leave a coil hanging out or whatever and see it arcing. Not a good idea. Number one, you could have some hydrocarbons under the vehicle, right? You may have something leaking like an injector or
Poof.
whatever.
Poof
and
goes your shop.
Then it's going to be a big fire. Okay.
But the other thing is, it does damage to the coils. That
Exactly.
electricity is going to find a path to ground. That coil may be laying on a valve cover or whatever, and it's going to arc right through the side of that coil. That coil may have been good when you started that test.
Now
It's not any good
so
now.
And here's the other thing. You know, when you're banging that coil out, boom, 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 all the voltage you could possibly put out, you could burn the driver up in the computer. We don't have modules anymore. You know, BMW always said they had the driving machine, right?
Yeah, the ultimate driving machine.
But you're supposed to take care of the machine. Here, people go press button and start. Oh, you never finished the press button. Did we ever talk about the press button?
No, we didn't. No.
You guys want to know about the press button? Say it real quick.
Okay. When you have a push to start, how do you make it crank a certain amount of time and stop? It's going to keep cranking. You lift your foot off the brake pedal.
That is an excellent tip because people don't know that.
It'll stop doing it.
And if you don't know that, you're going to have an issue. Okay. So thank you, Pierre, for running over that. I just noticed that on Facebook the other day on the ATS forum. So people don't understand that. Take the foot off the brake and you'd be okay. So here we want to see if we have a good gap of this type of setup here. About 40 thousandths or so would be pretty good if we have decent enough spark. Now, when you see something like this, it's not rocket science.
Oh, that's ugly.
That's ugly. This thing is worn big time.
That
Now,
was the coil was firing just fine. It just wasn't getting to the spark plug most of the time. It was going out to the well into the engine.
Now, here's the next thing.
Ooh.
Save your foil. Save your foil. Why do you want to save the foil?
It's your antenna.
Not two things. First of all, let's go back.
Oh, actually, two things. Yes, right. One is to find that short, and one is to hook it up to your scope to get a signal.
Excellent. Because right here, you wrap this and put it in the hole. You know, sometimes you got to go around that turn or got to be a little wet out. You wrap that with the coil, the foil on the wire going into the hole. It's going to go to ground instantly, and you're going to have the misfire. So save that hero sandwich or wedge or sub or whatever you
Unless
call
it's a little too greasy, then maybe get a clean
You
piece
know,
of
if
foil.
they had that chicken palm and all the mozzarella,
I think that's
or
not
some
a-
of them may say mozzarella,
Yeah,
in there, whatever.
Bottom line
Okay.
is,
It's not gonna be good.
it acts like a kind of an additional conductor, and if it doesn't make the coil go bad or the boot go bad, It makes it so you see that the boot is bad.
That's right. And sometimes when you see rainbows, it's not that stuff. I was just reading something about Gaelic Park this morning. That's a place down in the Bronx that had a lot of concerts. And 10 years after, Alvin Lee was a great lead guitar player. But anyway, it's not that bad stuff from that concert. You know what I'm saying? That
Not
you're
those
seeing,
rainbows that
not
are,
those type of rainbows.
in your vision.
I had a flashback, but that's another story, right? So here you wrap that, and if you have a problem, it's a good thing. Another thing here, get a bottle of water. This is not my hand. I don't wear gloves, but if you do, that's okay. Okay, water with baking soda. This is a good conductor of electricity. And yes, I know salt is, but salt is corrosive.
And do not use anything flammable.
Oh, come on, Pierre. Well, how about the brake clean? I want to see if the fire shoots up.
Oh, and it will.
It will. I love when I see people doing the spray test. I'm like, are you kidding me? So here I'm using my test light. Okay. I've already baselined it because this snap-on test light, it served me well. I still have the same light from God knows how many years
I have
ago.
one of those too.
And I don't want to go how far back, but it did break over the years. So always make sure your light works. Here's the other thing. So if you don't have a test light, you see my long screwdriver. Now you may have, any long screwdriver. You see the ground wire? I'm grounded to a good ground. I'm spraying. I'm having actually my son at the time spraying the water, a fine mist. Don't make a puddle. We go near the coil, near the wires, and if it's arcing, it's going to jump. This is a good ignition tip and trick. Now, how about this? This is on a Subaru. Okay, so it has a fancy blue alternator. I don't know who did that. It wasn't me.
Oh, I'm sure it charges better with that.
Oh, of course. Yeah, it was the super duper one.
Right.
What am I doing here? You see this vacuum hose? What I can do, even though it's rubber can actually send electrons through here, flow here. And what I'm doing with my test light that's grounded, I am playing cylinder balance test. I can cut one cylinder out at a time. So every time you think rubber is a great insulator,
the rubber
not
itself
so
can
good.
be a good insulator, but the air within it is a passage that can be ionized, and electricity can go through it.
So there, how many guys have ever used this? This was a great test, especially, when we had the big box scopes of yesteryear. You were easy to cut the cylinders out. Then after a while,
It got
weren't
tough.
so easy to hook things up and do a cylinder balance test. If you did, these are a little too close to each other, but on some coils, I would put little pieces of rubber on all of them, then get my grounded test light and go, okay, watch RPM drop, watch hydrocarbons and CO and O2 coming out of the tailpipe. Do one cylinder at a time and see what it's contributing to the total RPM.
Right.
And that way you could see maybe something misfiring, something not working.
Maybe not even a total miss, just like, cylinder balance, a weak cylinder,
Correct.
it's something a
Not-
little off.
You bet.
The hard ones to find, right?
Now, of course, this one, to do the real plugs and coils, you got to remove this whole plenum.
Fold over intake manifolds.
I want you to look at this right here. If you see all this dirt, and it's hard to see the rainbow color. What do I mean by the rainbow color? Like that orange purplish. What is really going on here, Pierre, is rather than the coil, this is called an e-coil, epoxy coil, sending all the voltage down through the little ceramic type of, if you could open this box up here for me while I'm yakking. This doesn't have ceramic one, but this Duralast coil has, and don't rip their box, has the boot going down. Well, that is either a wide gap or something arcing. It does open up there because we had it open.
You know what? I have a pocket knife.
Yeah, you may
And
need.
and he has fingernails.
No, I got no fingernails. I just
okay.
got fingers.
Okay.
And my favorite coil, if it ain't a Ford coil, my God. So here, this sometimes is ceramic, but even if it's rubberized like this, you can get little arcing through here.
Yeah.
This is the reason for the actual foil going around. And this is the reason for the coil overheating. The tops of these do overheat. And rather than it being beautiful and shiny and not a problem, it almost looks like dirt splinters. Have you ever seen it?
And I have actually. And if you ever see something where it's like a real blowout, that's blown.
Oh, blown.
That's done.
Blown. You got a comment or a question? Someone blowing something out? More than we needed to know? Okay, let's look at this thing that came in. And here we have a pickup right here on it. A copy.
Now that is an
Yeah. And we have Pete. You got to say something, or did you just sneeze? No, I thought I heard Pete. Okay, so I want you to watch this video very closely. Here we go.
and that is arcing away.
Right there. The arc was right there. So arcing can cause a problem. And obviously that is a misfire. Now here was another one we had on a Corvette that came in. And this being probably a C6, C5 then.
This is our second distributor we put in it.
This is OptiSpark on this thing.
High and low signal dropping out when it got hot and shutting the vehicle down. This one we have a misfire on cylinder 7. I just did a few preliminary checks, and now we have a good spark tester in there. This is on a good cylinder. I'm going to start it up and show you. It'll jump to 30 thousandths gap. 30K gap.
Look at that, lightning in a bottle,
But not always sparking.
but not consistent. That's correct.
Now, this OptiSpark, we had a couple of them being defective, which leads into a problem. Now, we made this video actually, well, I won't say the parts company, but for the parts company, it was like, oh, how could it be two of them bad? Well, dude, there was two of them bad, okay? And you got to remove the water pump to do this. If you've ever done one of them, it's not an easy job where you're just popping a distributor out. You're taking the water pump out and the whole bit. So not fun. Now, here on this actual car, which we're going to be doing live on, we have the e-scope hooked up with the crank ignition misfire. Now, I'm not sure if any one of you out there own this. If you own an e-scope, it is with the latest downware software, and it has to be on the newer version scopes.
It has to be the elite scopes.
The elite
Could be a
scopes.
4 or an 8 channel, but it can't be the old, like I have from 20 some years ago.
And
I
it
had
can't be this one either.
and it can't be the Pro, which was
The Pro.
not an elite. That the scopes, like everything else in life, got faster and more powerful. And even though this was a very good scope,
Great scope.
and so was the original 8 trace before this, or the 4 trace. The fact is they're just not fast enough to support this kind of test.
So that being said, here's what we're going to be doing live on the vehicle. You're going to see this crank misfire. And there's a lot of ways to skin a cat. We're going to show you from the easiest stuff first, like using this GTC 505 that can set you back maybe somewhere about $300 or so.
Maybe even a little less, but in that neighborhood.
In that neighborhood. And it works quite well. And we're going to induce the misfire using the
The Cop 3
3.
with the Mac Vandenbrink tool.
Thank
Right.
So we're going to do that. We also have a transducer in the tailpipe, the E-Misfire transducer. That is another great way to see if you have any issues with a misfire. And here, when you see something, you can go into deep record and actually plot out what is missing. And we're going to show you this whole process.
Now, other scopes will allow you to do this, but you have to use a math channel, or you have to use whatever. The point is, there's a lot of equipment out there. I've said this many times. Whatever you've got, learn to use your tools.
Right.
Use them on good cars. Use them on your car on some night of the week when you don't have the phone ringing constantly. But get used to it before you have an actual trouble car.
And I want to put just a plug in here. Even though Bernie, Bernie is a friend of mine. I didn't know him originally, but this man was the first guy to come up with the in-cylinder pressure transducer, patent it, this crank thing, put it in there. Now, of course, all the other people, you can do something with Mac channels on Misfire with Picos. Picos good stuff.
Yeah,
I own
yeah.
one. Okay, I'm not saying it's not, but he doesn't get the credit he deserves. So I'd like to.
Yeah, real
mention
pioneer.
that.
So the bottom line is this enables you to see what, well, first of all, do you really have a Misfire, or is that thing running rough because it's got a crappy, computer
about the
controlled?
motor
I was just going to say a crappy computer controlled motor mount, or some other problem. What if it's got some problem with the harmonic balancer that's off, or a crack in the flywheel, or the flex plate. That's we were thinking that along the same.
Yeah. And you can get a lot of imbalances from even someone who changed the transmission, and there's a torque converter issue.
Or something I just ran into. They have little locating dowels when you put the tranny in, and they took the old tranny out, and one of the locating dowels stayed on the old one, and they put a new one in, and now it's little like this, and that could cause all kinds of mayhem. Very hard to find.
We have a comment or question, Dory?
Have you ever had a plug wire shot out due to a spark plug? I was using the DTC to check for a misfire and the plug blew out. I saw.
Was it on a Ford? Because I've had them blow out on police cars.
I had a high KV with no spark line before it blew out.
It must have been almost all the way
Can you
unscrewed.
answer, was that a Ford? Because that was common on Fords where they would blow out. So I've had that. But
By the way,
I can't remember any other car.
Actually,
but that.
I've seen a BMW that had a spark plug back out of the cylinder, but I think that the owner of the car, who was
Didn't torque it, did it?
well, no, worse than that. He took it out and put it back in, 8 times, over torquing it. And now the gasket, and maybe he didn't torque it up enough the last time, but the point is that gasket couldn't crush.
Ford Focus.
There you go.
Hey, do I know my cars or do I know my cars?
Okay.
Here's another one.
There you go.
This is using a first look pressure transducer in the tailpipe. This is from John Thompson, no relation to Bernie, called Ace Misfire detector. And you can see here from pulses, he basically gives you, hey, I got a real bad cylinder, 2 on their way out, and 3 are good. So I'm running on 3 cylinders.
And
by the way, this is not a gas analyzer. You're putting a wire in the tailpipe like Pierre has over here going to the back of that car. Why don't you just go back and get it? This would be the next one up.
we can get into an unbelievably long dissertation about different types of transducers. This is a absolute transducer, inches of water. There's inches of mercury, and there's PSI. But the first look transducer that he was using on this other thing is actually a relative transducer.
Correct.
If you had 100 PSI on it, but it wasn't moving, it would be a straight line. But it shows change. But the beauty of it is it's extremely sensitive.
Right. So here, the Ace Misfire detector, another way of looking at it here. You can put in the year of the vehicle and the engine size and all that, the firing order. Tell it what the vacuum reading was, what bank you're getting fuel trim off of, and it would come up and tell you what cylinder has a problem. So this is high tech type of info that or equipment that you can use for Misfire, and that's pretty good. Now here's the ATS stuff where you can pick a particular vehicle, find the firing order, and go in with the Misfire software that we're going to be using on this particular vehicle. Okay, and it will show you what cylinder. Now we had a buyback from BMW on a M6 beautiful vehicle that the ISTA, the BMW factory scan tool, showed no misfire, but yet mode 6 and the Misfire definitely showed it. Now to give the customer a whole bunch of information on it. They did cylinder heads, they did injectors, but those were all pretty common on those cars. And then they wound up buying it back. You know why? Because she was an attorney. And this lady knew how to spend money, has a fleet of cars, but with the right equipment. And I remember them asking, I guess it was a zone rep out of New Jersey who went to the BMW dealership. And he's like, well, how are you coming up with this? And I explained everything because he looked at all the data. and he realized, hey, this thing had a problem. So they'll try to, fluff things over, but the bottom line is this can pick the pepper out of the fly dip. So it works real well. This is a real nasty motor.
Oh, yeah.
We hope Pierre's motor's not this bad.
I drove it here. I think it's
Oh, come
better
on.
than that.
I broke it when you weren't looking.
Oh, I guess I'm walking home.
And here is what you would typically find. This is a real bad vehicle, but look at this one here, showing you one cylinder misfired 332 times, and it's cylinder number 6 out of this firing order. So it's kind of nice when you have software like this that can give you a misfire diagnosis. And of course, that doesn't mean change a plug, change a coil.
No. It means diagnose the cause of a single cylinder misfire. That's what it means.
It's just another tool that we want to give you during this presentation.
And by the way, you could have an ignition misfire and put, all those numbers of spark plugs and coils in. But what about the power to that coil? What about the ground back from the coil to the computer? Or what about, especially if it's random through all the cylinders, what about the computer ground? You got to check the whole circuit.
And everyone wants the silver bullets. You can't just go for silver bullets. You got to do due diligence and check the circuit. We always say check powers, check grounds. You need to do it. Okay, we're going to stop right here and go to the vehicle. So now you won't hear us yakking more. We're going to do a couple of things right over here. So first thing, Pierre, let's start the car up, get the fan on. I'm going to have to speak a lot louder. I'm putting this on. And Pierre's going to start his vehicle up. I'm going to go over to the vehicle. I will probably go to the
Now, maybe before he does that, I should explain something.
Yeah, go to that camera right there.
So
We're good.
you see this thing here? This is that Mac Van Den Brink tool, and we've attached it to a coil, not the coil that he's looking at right this moment. And by hitting this button, I can create a misfire without damaging anything. Okay?
Go ahead. Actually do it. I'm on your coil. All right, I am on this coil. It's multi-spark, and when Pierre presses this, you see the waveform go in and out. And notice it does take the motor a little time to recover. So this does a real nice job right here. Now, another way of doing this, excuse me, is we're going to go to something called the comparison view. Okay, so I'm going to go back here.
That's cylinder 6 he's reaching for. Now you got to understand, for this engine usually has covers on it. Some modern engines with plastic covers, you could read right through them if you know where the coils are. But we wanted to really hook up with wires, so we took the covers off ahead of time.
Now notice I'm not really going super close on these coils. This thing picks up real well. You can see the difference right on that one. You got to tilt it a bit. So this thing does a great job there, something easy to use.
Maybe hold it up at a steeper angle.
I'm going to go to digital.
So I'll apologize for the lighting, but this always happens. You get reflections off the shop lights.
How about
Oh, that's too glary.
how about that?
That's a little hard to see. There you go.
No?
Well, it's there's
You
still
can't see it?
there's a little glare. Hold on, let me.
Okay, she's giving me the thumbs up.
Okay.
So you can look at here, you notice you got RPM, you got maximum 14.8 kV, minimum 11, and we're at 12. Now I'm going to go to the one that Pierre is going to kill in a second.
Tell me when.
Go ahead. Oh, hold on, I got it on hold. It does help when you have it off hold.
So that's,
Let it go normal.
it is normal, but it's trying to recover.
We'll go here for now. And this multi-spark, you see that's bouncing around? And here.
Because this one doesn't do 3, this one does like 6.
Okay, so you see how we're 16, 12. We're pretty well steady there, right? Now, I'm going to go back to this one. Let me get it in view first before you kill it.
It is jumping around.
Yeah.
We really did kill it. I'm going to hit this thing and make it really die, though. Let's see
You
what's
see it
going.
went 1, 2.
Yep. And you can hear it slowing down. Maybe I am walking home tonight.
Well, we got a spare vehicle that you can't use. Let me try zooming on that for a second. All right, I think that's a better view. Give it a shot. And again, it's really this easy. When you see me do this, all I'm doing is putting it near the system, and I know you can't see it there. There you go. So you can do a bunch of stuff with this GTC 505. It has a hell of a lot of different things. You got a chart, waveform. So there's the waveform that you've seen.
It's kind of glary.
There's the chart.
There you go. That's a better
And look
picture.
how far up that is picking it up. Because even if I go here to waveform, look at your peaks. That's how much voltage is coming out. Can you see that? That's banging out pretty good. So a real nice setup. You can do things like burn time. So if I wanted burn time, you can see our burn time measured right there.
And the multi-strike on that ignition, by the
Yep.
way.
And then we could go to ramp time. It's almost like coil ramping. And again, the nice thing here is you want the angle of the dangle, right? And then you can go to voltage. I don't care about tach, but there's my voltage reading. So it really is a great little tool. And now we're going to go on with, we're going to switch over to the E-scan and E-scope. Let's go in with E-scan first here. So the first thing you want to do with E-scan, he is going to,
Well, the first thing I want to tell you is you really have to VIN identify the vehicle correctly.
well, it came up with a BMW 3 Series.
Actually, it didn't come up with that. I had to enter it. It didn't
Oh, did
read.
ya?
What's interesting
I just
about
hit the
this,
button.
yeah, I know. Well, it was there previous. Now it's talking again. Or trying to.
Murphy's Law. You want me to unplug and replug?
Yeah, maybe so. So what I want to say about any of these tools while this is happening, if it has a database that's tied to a particular car, it's got to know what that car is, or some of these smart tests are going to, are going to be wrong. They're going to come up with the wrong values, wrong targets. In this case, the scan tool has to see the VIN correctly. I had 2 of this model car at one point. I only have 1 now. This is my daughter's car. And one of them would report the VIN and one of them would not. Same year, same model, 2 months difference in production date. Go figure.
So it's given us an issue there where we may skip.
Actually,
We could measure that in a minute.
When working on a multi-strut vehicle, at what point is the ignition complex do you measure the burn time?
Okay,
That's a hard one on multi-strike.
so multi-strike is a calculation by the computer.
Yeah, I don't think you could actually see
So-
that any other way.
So burn time is really the whole event from the very first strike to the end of the ignition after the last strike. It's burning that whole time. And the old rules they don't exist anymore for this stuff.
They're out the door.
Yeah, they're done. So what's
We got it.
important is that they're all the same, because different generations of these will be very different from, this is actually something we're not going to do today. It's an acceleration test.
Go ahead, Pete. Pete, can't hear you. So do we have any codes in there, Pierre?
Actually, it has something pending.
All right, so switch to this tool here. Let them see that.
We can't hear Pete.
Pete, for some reason, you're off. We cannot hear you.
Oh, here.
So this is a 1346. I think it's some kind of a false air code. Let me see if it's identified the car. No, it has not, because we restarted it. So now it knows what the car is.
We can't hear you.
So what's going on here is actually, we've been torturing this car, so we probably created this car.
Oh, come on, Pierre. A little torture for a BMW? Don't be such a sissy.
The point is, it's a pending code. It's not mature yet. Probably happened in the bay here within the last 15
Yeah, well,
minutes.
we did make a lot of misfires. How about going into mode 6? So now again, hold the car here.
No, actually, I want to illustrate this. So this comes up as generic.
All right, Pete, speak up because I need to hear you. We got motor going and fan going.
How's that? I'm sorry. So I didn't mean to. Back to the multi-strike question real quick. Another thing I'd like to throw out there for everybody. Burn time is one thing, but it's what you see in the burn line that can really help your diagnostics. Is it running a little lean? Is it running a little rich? One of the things I like to use the burn line for is diagnosing those intermittent misfires caused by an intermittently sealing cylinder. Again, as a trick that I learned from Mag Van den Brink, when you'll see turbulence in that spark line. In other words, you'll see it going up and down erratically through a normal length of time. And what's happening is that the spark, the firing across the gap is actually bowing in and out as the turbulence generated by that slightly leaking valve is allowing all that combustion pressure to find its way out. That creates a storm inside the combustion chamber that you can see on your scope. If you want to try it out for yourself,
Like that. It's good.
ground a plug up there on the cylinder head and use your blow tip to kind of lightly blow air on it. You'll see the spark moving in and out. And as that does that, it's just like a variable gap on the spark plug. And that's what is a good indication to help you catch some of those intermittent sealing cylinders for your diagnostics. Okay, got that out. Sorry.
Thanks, Pete. Okay, so being back here, Pierre, you go back to the generic. They didn't see that because Pete was on. So here is what Pierre, two P's there, two P's in a pod. Here's generic, where we are not selecting a vehicle. We do have something highlighted in red, as you can see, one or two above the blue line. Okay, now Pierre is going to select as close as he can to the right vehicle type for BMW.
And I'm going to reread because that was the old data there. Now, I could have read it continuously, but for purposes of this webcast, I'm just doing it the one shot. And look at that. It still doesn't have a description.
It's unavailable on an O2 monitor.
And it's something about O2 sensor monitoring, but it doesn't have the actual specific part of the test that it's
Right.
running.
And sometimes, depending on the year of the car, the manufacturer may not do that, or the scan tool manufacturer may not do it.
Right.
And one thing we should do here, now notice this is the one shot that it locked right on, right?
Yep.
Let's hit read continuous, and I want to explain what is going on the screen. Now, this should be flashing. This screen should flash, and if you looked at the red, watch the flash of the red, and you'll also see the yellow up there blink. So you see it just did it. We're going to do it one more time, and this means it's going, hey, who's there? Give me something.
It's getting new data, and they got to understand mode 6 is the individual tests that the computer is running to pass or fail various monitors.
Correct.
And so each one of those blinks is a rewrite of the data. The next test has maybe been done.
And you got MIDS, monitor ID, TIDS, test ID, and SIDS, component ID. That's what it's going. We get a test value, a minimum, a maximum, or in between. And as you see also to the side, you could have what they call units. Units could be in percentage, it could be volts, it could be amps, it could be some made up number like most of the time they do with catalyst monitors. So there's some info, and Pierre can scroll down here on the bar. There are a few more things that I am surprised, like O2 heater circuits that they had on this. Okay, so we're pretty well done with this part. We're going to go on to Misfire stuff. Any questions there for us? No questions.
This is the wrong tool. Let's go into Misfires. So this is with the scope.
So we're on the E-scope here.
Now, we generated this before. This is actually not, this is this car, but it's not how this car is running right now.
If it was running this bad, you'd have some
It
problems.
would be running pretty
I
well.
told you, maybe I didn't want him to go home. You know, we got to do another webinar I got to do tomorrow. Then the next day, Thursday, another one.
So the bottom line is, this is how it would flag it if we hadn't been, deliberately screwing with the car and making it bad. Now on this car right now, it would be pretty smooth. Actually, I'd probably have to cycle the key to successfully do this test now, because there might be a strategy in place from us having done the cylinder kill.
I think so.
In fact, I think I'll cycle the key right now while you look at that.
So I think Pierre is absolutely right. I can tell when he did knock it out a few times, meaning killed the cylinder by pressing the button on that cop 3. Sometimes that will throw something way off you, way off.
In fact, if you introduce enough misfires on a lot of cars, BMWs are one of them, it sees it as a catalyst damaging event,
It'll shut it down.
It'll shut off the fuel injector, and it won't turn it back on until maybe the next key cycle, maybe even until you clear the codes, depending on how bad it saw, what it saw for an error.
True.
So to do this test again, we'll go back and do it again.
And let's go on that screen. So here we go.
Now we're going to have to, this test requires 5 seconds. So right now it's gathering data. And as long as we have 5 seconds, I'm not going to have a misfire in here. I'm just going to let it sit.
Yeah,
now we're going to have to wait.
Do its own.
We're going to have to wait while the logic does its thing. Because
Well, that's okay. I need to take a sip of water.
there you go. Because this actually takes a while. There's tremendous, this is using, this scope has something called fast capture. It's a much more data intensive sampling rate. And it's doing analytics on the waveforms to the crank signal versus the ignition to figure out, there you go. So it's
Switch
done.
that to the screen. There we go.
It's done its calculation. This is the rough one. You can see there aren't any misfires. And when you go back to the tool, it'll give you numbers that are very specific on the actual number of misfires. It actually sees a few misfires.
But you got to remember, every motor actually misfires, right?
A little bit, right?
A brand new motor. Well, if we said you're 25% efficient, let's say, for argument's sake,
Yeah, it can't be firing perfectly all
can't
the
be
time.
firing perfect. So it misfires to the degree of misfire is a different story.
Right.
So here, it's not enough to make a check engine light come on
Right.
or make the customer feel uncomfortable. Watch when we do make it, when I press this button.
So
right
now I'm going
back
to do
here.
the test again. Wait a minute, I got to get it
Yeah,
started.
I'm just getting this in my hand. This is like a detonator.
Okay, so I've started the test, and at any point, Jerry will hit the button real quick, a couple of times.
You let me know when. Ready?
Go.
Here we go. You could hear it.
And
Hear
now
that?
I'm going to stop the test, and we're going to go back
And that's
to this,
it. I just pressed it. I'm done.
and it will go back. And now, again, it takes a little while to analyze the data because there's a lot of data involved here. And it's going to see that it had a problem.
And we should say, Pierre, we're connected to the crank sensor. And what it's doing, it's seeing crank interruption %.
It's basically doing an analytic on the crankshaft signal speeding up or slowing down. And it's still doing its analysis. It hasn't finished it yet. And it's also using an ignition event as a trigger just to know when to start again.
Do we have a question?
I got,
Go ahead, Pete.
another comment there for you too. I mean, if you think about it, what we're doing is exactly the same thing that the computer's doing. In most, not all, but in the majority of vehicles on the road, the ECM is monitoring the same thing and looking for the same thing. So this is the duplicate of that test. What better way to look for the misfire than the same way that the car does?
Right. Now, I agree with you there, Pete. The computer, the PCM, does look at the same type of test. But that being said, if cam and crank are not synced, it doesn't always work too well. You may get misfire on the wrong cylinder. You may not even pick the misfire up. That's the beauty of this tool. You
Yeah,
can
and that's very
actually
good
find
comment.
misfires with the tool.
This thing still says it's analyzing. I hope it's not like, taking a coffee break or something,
That's long analyzing.
That's a lot of data. Well, I think when it sees something erratic, so we created an artificial misfire, and I think that
I think it's quicker.
that when it's a real thing, it has an easier time analyzing it. When it's something you've done by messing with the whole operation of the car, it probably has a little, and probably going over this data about 8 times.
Well, and we did play with this before.
Yeah.
Maybe we'll try one more time.
Okay, let's. It may not let me because it's in the middle. Let me try it.
We're going to try to reset it if possible.
Yeah, I'm going to see if I can. It won't. Yeah, it won't.
It won't let you do it?
I'm going to have to reboot actually.
Okay, so he's rebooting the scope part of it. Did you do that or not?
I tried, but it's not accepting it.
Oh,
It's in the middle of an operation, and it's stubborn.
That can be a problem in the middle of an operation and have a problem, right?
So here's the bottom line. I love this tool. I'm now kind of full disclosure. I also provide technical support for ATS, but there are a lot of tools out there that can do a lot of jobs. Said it before, going to keep saying it. Whatever equipment you've got, utilize it. I think Pete actually said that in a recent webcast. The worst investment, the worst tool you can buy is the one you're not going to use. And the best tool you're going to buy, even if it's not, the pie in the sky one, is the one you are going to use effectively, successfully. We really confused it with that last thing.
Doesn't like it. Murphy's Law.
Doesn't like it.
And it won't let you reboot?
And it won't let me reboot it. I may have to reboot the whole thing, but I don't want to do that if I can help it.
We may have to in the sake of time.
Yeah, so
while we're waiting, we will entertain any questions or comments you have, and we will go over a couple of other things here. Again, I would like to thank our sponsor, because we can make this webinar free. And I believe we have, and Pete, correct me, I don't know, 5 or 6 next year, I forgot what it is. So thanks to different sponsors, this one is our friends at Duralast, okay? So we thank them because you're getting information that is worth money for absolutely nothing, thanks to these guys. And of course, here on TSTN, Pierre and I donate our time, and Doreen behind the camera and keyboard there, and of course, Pete. So as we're waiting, I am also going to pop this up here. We have PAVE. If you haven't heard about PAVE, pavetraining.com. It has over 55 great classes. I'll be doing one of them, 4+ hours, a lot of it on car. We got Thornton, Sanders, Thompson, you name the guy, my buddy Wayne Colonna. You have management, like my other friend Vin Waterhouse. You can go on and on, Bill Haas. So there's management, there's collision. I don't know all the collision guys except for Mike Anderson, who is phenomenal. But there is a large group. And if you guys go to pavetraining.com, you can save money by going to the TST drop-down menu and signing up. So you go there, click on it. We'll be live in 2 days. It's a 4-day event from, do we have the date on it? There we go. December 2nd, Thursday the 2nd at 12 noon Eastern time, as I always call the real time, all the way to Sunday. So you got Thursday, Friday, Saturday, Sunday, and then you have time with the sponsors. This is all done off a great platform, a little different than what we used last year. So you can speak to the sponsors, you can watch stuff. There's AE Tools, there's Napa, there's Dorman Products, there's a bunch of other ones there. Thanks to them, they can reduce the price of this phenomenal training. And even if you miss it, you can see it for 30 days, which brings me back to our side. When we're done with this tonight, Pete will, in his spare time, put this all together, and we will make sure it goes up on the Motor Age website, as well as the TST website, for your viewing pleasure, okay? Or maybe not. Maybe you're sick and tired of me, and you want Pete back. So you can write, give me Pete back. Pierre is almost there putting this thing together as I am rattling on. We'll do another plug here. So please go to www.pavetraining.com. And then we have with TST, and we're proud that Motor Age is one of our sponsors, besides many others, the TST big event, March 19th, 2022. It should be live in person from Terrytown, New York, a great area about 20 miles north of New York City. Really nice Hudson Valley area. We also always have good stuff. This will also be a simulcast. So maybe you live too far away, don't want to get a hotel room, don't want to be around people. There will be restrictions as of now here in New York. We do have to wear a mask, and masks most likely will have to be worn as of today at this event. So some people may not like that, but there's nothing we can do about it. There are other venues out there that have to do the same thing, and some in different states that don't have to do that. Pete and I were teaching down in Florida. There was no mask mandate there. Out in Texas, there was nothing. Vegas, we had to wear a mask. So depends where you're at. We would like to see you there at the TST big event. We'll have some great speakers, and you can meet myself, Pierre, Pete, and many other people in person. Okay, we do get a good crowd coming out. Here, you're ready to go on that?
Yep, pretty close.
All right, so we're going to switch over to the computer screen.
I'm screwing up with my cursors here a little bit, but you
Close
get the
enough.
idea.
Close enough. Oh,
We lost our link to the computer.
we should reboot.
Yeah,
That's
because
why.
I had to reboot. Hold on. Sorry about that. Technology, ain't it wonderful?
Now we go here.
So, oh, by the way, you know what we forgot to say at the very beginning? This is live on a car, and things happen.
Now you can go back. You can go back to the scope. I got it. Yeah, stuff does happen, and when it happens, well, you know,
That's
it's
the way it is.
By the way, when
About the tickets for the big event.
tickets for the big event. Well, let's talk about that for a quick second. The big event is most likely not going to have the full amount of people, thanks to the state government here in New York, but tickets will go on sale we're hoping in another week or two, TST website is being updated. Okay. So we have to depend on the new web people we hired. And I just got an email this morning at 6 o'clock telling us they may have it up within a week or so. So maybe it'll be a good Christmas present for you.
There you
To
go.
actually get yourself
And,
a ticket for
You know,
the
you
TST big
probably
event.
want to do it earlier because we don't know what kind of limitations are going to be placed on us. The governor just put a state of emergency to effect for
You
I
have
guess
to get me
hospital-
aggravated. Let's not go there.
hospitals and things like that. But we just don't know where this is going.
Right. And if, you know, it's delayed or canceled, I mean, it'll be beyond our control. We did have that problem a couple of years ago. Last year, we did the whole thing during the pandemic live. We gave you extra. We went out 2 days.
But it was virtual.
It was all virtual. You know, only we were able to be here, but we will do that.
Do you have an agenda for the big event?
The agenda for the big event, we have a couple of speakers that we're not releasing right now, a couple of different people. We're trying to change it up. We will say our upcoming, we have Isaac Rodell for our TST December, and it's a special deal. Non-members only $20, members $10. Our holiday, so now it's Hanukkah. Happy Hanukkah to you out there. It is Christmas. Merry Christmas. Happy Kwanzaa. Happy whatever.
And after
So-
that, Happy New Year.
That's right. See, I'm covering all the bases. So we're doing a special that, I don't know, is that up on the website for Isaac yet or no?
It's up there with emails on it.
Okay, so it's up there, no email out. And then we got George Menchu coming out. Now that is a special because George does not do a lot, but he's been a good supporter of TST.
For
And
ages.
We're glad
Decades.
to have him out. Joe Hyde will be January. He does Christian Brothers. He's head of their technical department. He will be doing Nissan scan tool and drivability. And then George will be doing a great updated electrical class. And then, of course, the big event with 3 great speakers and our keynote. I will tell you the keynote, our good friend, Carm Caprietto, will be our keynote at this big live event. Limited, like Pierre said.
Yeah, and we don't know how limited it is yet because, you know,
Okay,
we don't
I'm
control that.
commercialed out.
Okay.
So,
So
let's get back to this.
because I just happened to boot up in this mode, this is the multi-strike on this car. And as you can see, there are
blow that up.
6 of them. I
Yeah,
mean,
so unlike cheap Ford that only has 3, we got 6. And look at that spark
let
line.
me turn off some of this other stuff just
Yeah,
so you can
don't
see
confuse it. Oh,
it. Oops, that was
right,
the
there
one
we go. Now look at this spark line right here. But these are 1, 2, 3, 4, 5. Whoop, 6 of them. Sorry about that, Pierre. I thought you
That's
had a lot.
okay.
We don't see it from here.
Oh, well, I was counting. You know, I had Sesame Street schooling, so I needed to count. Excuse me. Wow, that is a beautiful picture. Now, this is primary ignition. You may go, well, how did you guys get that picture? We are back probe at the ignition coil. And on this particular system, that Pierre, this 2-wire system, I think, when I was over there.
No, this is a
3?
3-wire system.
3-wire, okay.
Each coil has its own ground. It has a power, and then it's triggered by the engine computer, the Motronic unit.
Now, when you see more than 3 wires, you're not going to get this type of signal. You're going to get a square wave because it would have like a built-in module.
Yeah, so in those cases that Jerry's talking about, you're typically going to see a 5 volt. I mean, some of them use different voltages, but
Usually 5.
the typical is 5 volts. And that signal is just telling the coil, which is a module,
The fire.
that's the dwell time. And when it releases, that's when it fires.
Yeah.
But the rest of those calculations are done by the coil. And that extra 4th wire from the coil is generally some kind of feedback information, which changes dramatically manufacturer to manufacturer back to the engine computer to tell it what happened.
Yeah. So you got your cursors up. Were you
I got
measuring that out for them?
I'm measuring that out. So actually, I'm a little off because I was being a little too flaky and fast.
That's close enough for government work.
6.177 milliseconds. So that's effectively the burn time on this at idle. That's quite a long burn time for idle, right? But
That
they do
is.
it that way for emissions and for smooth running.
Yeah.
Now look, I'm gonna show it to you. I'm gonna rev it up a little bit. Actually, maybe
I'll
rev it up, Jerry. We're gonna record the same thing, exact thing again. Only this time, when he revs it up, you're going to see that it disappears.
You can see the holes in the picket fence, per se.
So now, it's good. I'm going to, again, home in on it at the beginning. No.
No, this is a non-GDI car. This is a older vehicle here.
So this is a 2003.
2003.
It has traditional sequential port injection, electronic, normal stuff. So now you see the signal from when it's revved up.
And it's one shot.
And it's one shot.
There you have the dwell time as the voltage drops down.
So maybe I should put cursors on it just to illustrate all
And
this.
then you got the amount of time from where he has that first cursor. Actually, to here, that is dwell on time.
Well, I missed it a little bit.
And
that's
the
dwell.
coil.
So that's the time the coil's charging.
Right, and that's
then-
the firing right there.
And then this time is the actual firing.
And what is that, about one something? Like one and a half?
1.445 milliseconds. So yeah, that's kind of a normal time.
Yeah. And look at the coil ringing. Nice coil ringing.
Yep.
You got to put like your pen there. They can't see our finger. So maybe just like do a circle or.
So the two things are, number one is all of this turbulence, which is around in here. See that?
Yep.
And then these oscillations are from,
The ringing of the coil, as they say.
So that is the reserve. I actually should have put that second cursor a little to the left, but the point is that is the residual energy that the coil has after the fire has stopped. That tells you that the coil did not run out of power before it ran out of fire, so to speak. It wasn't underpowered.
That's true. Okay, let's move on because
Okay.
Pete wants to get to sleep, he said.
Really? Well, why did he come?
Why did he do this webinar with us?
Don't blame it. Don't blame it on me, bud. Don't blame this on me.
We already put you to sleep. I'm sorry, Pete. I can't be responsible for this guy, Pierre.
Yeah. No, I'm pretty.
I take no blame.
Yeah, that's it. So we have a crank signal up here. We were going to do, we already kind of did that anyway, the misfire analysis, right?
Well,
Maybe-
we'll try to, but first show them all the signals that we have there.
Okay. Actually, let me just go out.
So there's our ignition in red. There
So
is the
ignition
crank.
for cylinder 1 in red. We have a crank signal, which I should actually zoom out a little bit to give you 720 degrees, because that's normally what we would do. So this is 720 degrees.
Right there, and you can see it.
So you see now, of course, because the ignition is a much bigger signal, the crank signal looks very small. But if I ignore the big part of that and just go for that, now we can kind of see the relationship, right? And that's just 720 degrees, barely. I'm going to have to turn off the crank signal.
Upside down.
And I
It's inverted.
had it inverted actually, but I shouldn't have. But this is ignition from that COP 3 tool on a different cylinder number 3.
Correct.
Same kind of information, but the other way around.
Yeah, it's just inverted right now, and you can't switch it. You took it
And
off. but it
we
won't
actually tried on channel 4 to be on the actual ECOP tool, but because the design of these coils makes them unreachable, I couldn't actually reach it for that signal. So we can't get a secondary on
And
this.
how about the, oh, well, yeah, we picked up something on the secondary.
We did, but it was very hard to see.
You want me to try moving it and just show them?
Hold on, let me see if I can grab it with this. It was off the screen someplace.
And that is, what color channel was that in blue?
Yeah, no, it's not giving us.
Yeah, let me move it.
Okay.
Let me try moving that because I think it fell away when I was over there.
Oh, we got something now this time. Okay,
Oh,
let's
there
try-
we go. See, I moved it next to it.
Yeah, let me just try this and we'll compare these.
So this is secondary using a ECOP, the new improved ECOP from ATS.
Now again, we're idling, and because we're idling, we have the 6 strike, right? So each one of these is one event.
And you can see
Now-
the 6 shots.
Now, I want to point something out here. I'm going to point it out with a cursor here just so you can see it. This guy right here and this guy right here, this is the total time that the coil's being charged. But if you look at it, it only pulls it to ground very quickly and then immediately decides that the coil is saturated and starts to reduce the amount of pull on it to control coil saturation. Otherwise, this thing it's a pretty low resistance coil. It could smoke itself pretty.
Right.
And the
Low
smoke,
resistance, high amperage.
it could smoke the computer as well. So
No
that's
doubt.
their strategy. All right, and that's with an ECOP. Now, again, whatever tools you've got, use them. What you're looking for is consistent patterns here. You get a very different picture with a capacitively coupled piece like this ECOP as opposed to a primary ignition or that old metal clamp that Jerry showed you around a spark plug wire. Those look
and
differently.
you know, that metal clamp we talked about, no one gave us the answer about the aluminum foil. Well, what you do is when you have that, you take this and you take aluminum foil, crush it in there so this fits on the foil. The foil then goes like this over a coil. You make a little dome as long as you don't hit the grounds on the E-coil. So for example, if I did it right here, if I made the foil come down and I'm not hitting any metal and I'm over the coil. So think about the foil right here on the coil. I will pick up the secondary signal because all it is a big field.
And that's what it is. It's basically acting like an antenna. Now, just be aware, I talked about this before. Some modern coils are heavily shielded.
Heavy.
And
And it's difficult to get a reading.
and sometimes, I mean, it's going to be different with every one. We've tried taking the windings from relays. We've tried crank sensors and cam sensors and anything with a winding in it, ABS sensors, and they give us results. But the thing is, it's very hard to get consistent results. You can get something, but it's hard to compare one to the other when you can't even get it consistent
That's
across
true.
the same motor. So
Now-
it's tough. It's a tough problem.
Let's move on to, you want to try that misfire one more time or not?
Yeah, sure. Why not? Go for it. We won't freeze it up in the middle this time. Okay, so I'm just going to run it, and somewhere in the middle, Jerry's going to create a misfire a couple of times, and I'm going to stop it. So
So
now
right
we're going to have to wait for it to analyze its data. Now we didn't totally torture it this time like we did last time. I think what we did last time is we created so much data that eventually it would have finished its calculation, but eventually we'd want to go home too.
Not a bad idea.
So
But here, we want to make sure you
So-
understand what's going on.
So this is fast sampling the crankshaft signal, and it's looking for speed ups and slowdowns, doing an algorithm to analyze the relative speed of basically each up and down to the next one over multiple fire cycles, and of course using an ignition trigger to time so it knows 720 degrees.
Exactly.
And then and it's doing that math now on all the data it already collected, and now when it's done, it'll pop up.
You know, this is like when you're on vacation. You know, it's like that Chevy Chase movie, Christmas Vacation. Are we there yet? Are we there yet? Well, we're waiting. We're
So-
saying that.
Obviously, this is something that just has to do the math for you, and it's it takes a little time. However, it's a very good quick test. We actually have a different way to find a misfire. This is the more old school test. Once this is done, where we put inches of water, a very sensitive absolute pressure transducer in the tailpipe, and still trigger on an ignition cylinder,
Right.
and kind of get a similar type of reading,
From pulses.
for pulses at the tailpipe. It's looking so. There you go. See, look how long that took. We could have had lunch. So,
I could have went home.
and it saw a bunch of misfire events. Wow, isn't that funny? So,
And look what cylinder it thought was the worst.
and well, let's go back to that first. Actually, in this case, we confused it. Look at that. We only killed one cylinder, cylinder 3. Oh, you know what my problem is? I screwed up.
You said it was a 4-cylinder. No wonder why.
I rebooted the computer and the program, and that's part of why it had a problem. It defaulted to a 4. Oh, so remember about using tools all the time?
No, I think that's the other tool called getting old.
Yeah, that. So
Nah, it's just
I
just a common mistake we can all make.
we had it set up properly, but here's the thing. I rebooted the program, and it defaulted to a 4-cylinder mode.
Always got to
and-
check.
And so, by the way, this is also one of those cute things about live broadcasts or whatever. Stuff happens, but this can happen to you in your shop, and you can go, "Oh my, this engine's bad."
Yeah. Make sure you double check all your settings. And
All the
that,
settings.
that really is a good
Because
thing.
in this case, I don't know if we want to go through
Well,
this.
let's see. It probably won't take as long. When
Right.
You pick the right thing.
153624. At least that's 6 cylinders, you know.
Oh, hey, I didn't see it either. You know, half sleeping.
Okay, so it's collecting data, and I'm just going to hit it once because
Let's
that
see what
should
it
be
comes
enough.
up with.
Now it's thinking about it and
Analyzing data.
analyzing data, and so now that we have a 6-cylinder engine producing a 6-cylinder test, it should be a little better, right?
Well, we hope so.
But
Maybe someone stole 2 of your cylinders.
I knew it was a little low on power.
There we go. We're there.
There you go. So it had a lot better time now, didn't it? So, okay. So we go back, but you know what? It's still flagging as kind of yellow 4 of the 6 cylinders.
We're definitely.
Now, I'm going to say
Confusing.
this, even though it sounds like it's running perfectly,
It's
the
not.
fact that we created this event intermittently, it's very possible that this car has started a new strategy to compensate for its own rough running situation.
Yeah. Let's switch over to the one in the tailpipe, and we'll get them out of here in about
Yep.
a few minutes.
So in this case, we set things up a little differently. Just give me a minute.
Yeah, and normally it does
Do me a favor,
work.
switch this to the other
Which one?
channel 1 to the
Oh, yes, to the port.
yeah, and I'm going to reset this.
So we're just making a switch here, and you're in.
Yep.
So stuff does happen in the real world, right? And if you come across something like this, I mean, normally it works good, but like everything, you may run into a problem. Always double check to make sure. Don't run one test and call it a fail. Try it a couple of times. Repeatability, when it comes to something like a misfire, is important.
Now I'm going to use the IEA test instead of just the scope, pure scope.
Yeah.
Because that is the software that's designed to do this. If it ever lights up,
Gonna boot up.
maybe.
Good old Windows wants you to go to Windows 11 before it's over.
By the
We
way,
can't do that yet.
you got to be careful. Windows 11 is really made for some new architecture computers.
Right.
It might end up crippling you. I think I'd,
I would
wait on
stay
it.
away from it now. Besides, no one, if you're using your computer for programming or whatever,
Honestly.
no OEs are using it yet.
Right.
So I wouldn't do that. Stay with,
Oh, there we go. Finally.
this tablet is new, but I would stay with Windows 10 Professional. Okay, you can switch to that screen so they can kind of see it.
Okay, so so this is the dedicated software for Misfire. Now we can, we're going to select what it is.
So you're going to pick the year.
I'm going to pick the year, and I'm going to pick.
Make sure it's 6-cylinder, please. I'm going to tell Elisa, she'll be mad that you sold 2 of her cylinders.
Yeah, I know she will.
And by the way, you see the picture to the right of your screen was showing you where to put the transducer, where to hook stuff up.
Right.
And now the firing order came up.
Right. So now you can go into your Misfire screen.
Here we go.
And you can do the test. All right. Now, so this is using exhaust pulses. And again, if I introduce a Misfire.
Now this usually picks it up without a problem.
So it had a little problem.
Why don't
counting.
you put it on the other control? Can't see that. Right there. Okay. So make
Want
a
me to really
misfire.
kill it?
Well, do a misfire. There you go.
There you
And
go. That was
cylinder-
pretty accurate right there.
Yep.
So, oops. Well, of course, there you go. So that stopped it, but that's, what we can do. We can do that again, but we'll freeze it when we're.
Ready? I'll do it. You control that.
I don't have an F5 here. That's easy to reach, though. Okay, you hit it. Okay, so this tool flagged the correct cylinder, which we killed.
It told us the number of misfires,
Now,
percentage.
We didn't do it very long. We only did it for 6 misfires because you're hitting the button for a second or whatever, and then it's done. But it definitely flagged the correct cylinder. And now you have a real misfire as opposed to one of those other wonderful things that we don't want to think about.
And again, with this patented Venturi, this is a really great tool that we've been using for years. There's also a straight hose just for cranking. This is for running Misfire.
Right. Yeah. There's a straight hose that's used for in-cylinder cranking compression or running compression. Different.
And we're
adapter.
only hooked up with this wire to the box that goes to the back of the computer.
Right.
Now, with that being said, we know your time is valuable. We do thank you here from New York, and we'll get Mr. Pete back up. And on behalf of Motor Age, TST, he's Motor Age. Where are you, Mr. Pete? Don't confuse.
I'm here.
Okay.
I'm here.
So we're shutting all the noise off. Kill that fan too, Pierre. That way we. So we want to thank you for coming out. Do you think this was helpful to you? If you think it was helpful, put the letter H for helpful. If you think it wasn't, well, then let's see.
Well,
What
if you have a thumbs down emblem,
They
you
may
can
not.
use that, but there's no.
then give us H for helpful and Z for no good.
Well, I was going to say U for unhelpful.
Well, okay.
See?
I couldn't think of it. It's getting late.
Uh,
But we do thank you for your time. And Pete, we always enjoy working with you, my friend.
yeah, same here.
We've been doing this quite a while now. We've said this in other webcasts for, 10 plus years. And, we're the original dudes doing it. There's a lot of people out there, and we try to give you good content. We will take suggestions on what you would like to see. And Pete, maybe you could clue them in on what is coming up, I think in January, if I'm not mistaken. But
Yeah,
you would know that better than
it's like the The demand has been so great that we're doubling up next year. We're actually doing 8 of these webcasts with TSD starting January 2022. So yeah, you'll see us twice as much. Hopefully that'll be a plus for everybody who's watching. And as G pointed out, these have been sponsored, which makes it great for everyone concerned. It gives, covers our costs of doing business, and it allows us to provide this information to all of you at no cost. So that's a win. That's a win for everybody. I will say this, it's kind of weird that to do this remotely. Of course, we had a few hiccups along the way with all the buttons and bells we have to push and monitor while we're doing it. And I got to say, G, it's freezing down here in Tampa tonight.
Oh,
So it's almost like being up there with you.
Back up here.
It's like being up there with you. But yeah, in January, hopefully I get to come back up there again. We can do it the old-fashioned way and have a good time. And as G said, and Pierre said, we really appreciate y'all coming out tonight and hanging out with us. I apologize for everything that happened on the 20th. But boy, I think we gave you a smorgasbord of information to dissect and review. Of course, this video, because it's being hosted on a YouTube player, will be up and ready to review probably within a matter of hours. Right here, we are watching it right now. So with that being said, G, hey, from Tampa, Florida, I'm going to wish everybody a Merry Christmas and a very Happy New Year. And I'll see you again in 2022.
You got it. And from New York, I'm G, and he's...
And I'm Pierre, and thank you. Good
Thank
night.
you, and happy holidays, happy Hanukkah, Merry Christmas, happy Kwanzaa, Happy New Year to you and your family. Thank you again.
Good night.